this.
Thank you, Jirka. I give you the opportunity back in a few minutes to be presented. So in the meantime, thank you very much. I think most of you survived of yesterday night, so it's a very good feature. And it seems like it was nice, decent, good, very good. Okay, so great. So that's perfect. And we start the last day of the conference today. And we, of course, always want to thank the sponsors that make this, this conference possible. So we'll start by someone that has to tell us something about 25 or something, I'm not sure. But yes, Garett, please go ahead.
Yeah, there's a tradition here to wear fancy things on your head when there's an anniversary. I think we had these bunny ears for the XML
long
anniversary.
Time ago, yeah.
And last month, our company had its 25th anniversary. So our company, yeah. And this is what our employees gave us for the party. And we gave them this anniversary t-shirt back. It's entitled, "You Are Our Main Matter." So, you know, we are not just doing XML, we are also doing LaTeX, and main matter is, of course, a LaTeX macro. LaTeX, or tech, is like 20 years older than we are. XML is 2 years older than we are, but we are 6 years older than XML Prague, I think.
Yes, that's true.
What else can I say? As I said, this is the t-shirt that we gave to our colleagues, but today it says, "You are our main matter," and today, of course, you are our main matter. We are happy to be sponsoring not only the financial part of the conference, but also our in-kind sponsoring with the Leipziger Lerchen, Leipzig Larks, the pastry, and the student tickets. Today we only have 2 students. Yesterday we had 1 more. He had to leave early today. But this is also a tradition that we want to keep. And also we want to keep sponsoring not only XML Prague, but also Balisage, Markup UK, and Declarative Amsterdam for the upcoming years. Thank you.
Thank you. Thank you very much. Thank you very much. Oh, yeah.
I have a spare t-shirt. Who guesses correctly the first year that I attended XML Prague can have it. It's XXL. It's not XML. It's quite baggy. So, but you can on the Slack channel you can guess the first year when I attended, and the first correct answer will get it.
Okay, sounds like a challenge. Yeah. Thank you, Garett. We also have the chance to have our sponsor, Saxonica, represented by Norm today.
Thank you very much. I will make an effort next year to bring a tiara with me. I'm going to be brief. I just want to say thank you and say how much that we enjoy contributing back to the community and supporting the community events. Some of you may know that in October of last year, ownership of Saxonica moved to an employee ownership trust so that Mike can slowly retire. Very, very slowly, please. 2040, 2050, that'd be fine. And the reason I mention that is that the trust deed includes in it the obligation on the trustees to consider the impact of our decisions on the community. That's our level of support for making sure that the community is there and that we're doing what we can for it, because you mean so much to us. So thank you very much.
Thank you. Thank you, Norm. Also, we have the chance to have Antenna House being one of the sponsors, and also was there for the first day in the pre-conference, having some presentation. So please, Alex.
How's it going? This thing on? All right.
So my name is Alex Critchfield. I've been with Antenna House for about 20 years now. Some of you might realize that I am not Michael Miller. He is still with Antenna House, and he is still signing my paychecks, but he has stepped back from traveling, so for better or worse, you guys are probably going to see some more of me. I just want to say that I'm really happy to be here. This is my first XML Prague, and I am absolutely in love with the city. Probably the first one. I want to thank everyone for the opportunity to be here, and I want to ask you guys, how many of you are currently Antenna House customers? A few? Good, good. I want to say that we appreciate all of you. We know that you have many, many options for generating your documents, and we appreciate your business. Now, of those customers, how many of you have contacted Antenna House support?
Interesting question.
Okay. And how many of you have had good experiences? All right, good. And that's one of the ways that we try to appreciate all of our customers. All right, so feel free to contact support anytime you want. There are no dumb questions, there are no small questions. We know that our products are not always the easiest to get started with and use. We know that there's a lot of features that they have, but the specific features that everyone wants might be buried somewhere in the documentation. It's not your job to be experts with our products, it's our job. So let us help you. And we're very happy to sponsor this event, and I'm going to ask you guys to do a little bit of homework. That is, go to our website, www.antennahouse.com, and take 3 to 5 minutes and take a look over our products. We might have some things that could help you out in the parts of your projects that aren't currently using what we do, and we try to make the best products. We try to make them the most usable, the fastest, the most reliable, and that's all.
Thank you, Alex. Thank you. And thank you, Antenna House, to sponsor. Boris, long story between us.
Yes.
Can you say a few words?
2 words.
2 words, okay.
Dobré ráno. Good morning to everyone. I worked many years in the Institute of the Czech Language of the Czech Academy of the Science. I worked on electronic dictionaries and digital editions, and I used XML technology from the beginning. So I realized that it's really nice that we can meet here in Prague, and this is why I sponsor this conference from, I don't know how many years, but
Some.
yeah, some.
Yeah.
Some.
A lot.
So please enjoy all social and technical events in this year, and I hope we will see for 2 years again.
Yep. Thank you. Thank you very much. And now I'm handing back the microphone to someone I didn't introduce yesterday. He is the spouse of the wife. If you don't know, this is an insider joke. Jirka Koček.
Okay, you should say it's just the first name because you cannot pronounce the second name. So this is why I haven't tried to properly announce your last name. Okay, so we will continue with sessions, and first presentation will be from Karin. So welcome, Karin.
And I think I'm on, yeah. So, a different twist on XML is to start you off this morning. I want you to think about the future, or actually the past. Or, where are we going with this? So, I'm Karin Bredenberg. I'm working at a municipality organization in Sweden named Sydarkivera. If you translate that to English, it's South Archiving. You might see what I'm getting at. And the thing is that the data we create today, all of us creates data, needs to actually be saved for the future. We have regulations saying that we should save our data. And the thing is that when you think about saving things, you think about archivists. For a long time, there were people in white coats and sort of lab coats. They were hiding there in something, stacking paper. Today, they need to stack the digital stuff. And quite frankly, they are archivists. They need us. We need to help them. We need to make sure that everybody's data is saved. And yes, I know we can't save all data, but there are regulations for that as well. So we do create data. Every minute we create data. Remember when we switched and said we were not going to print things? People are still printing things. But moving this data around and taking care of it, actually XML is a key. It gives us huge benefits in making sure that it actually is preservable for the future. And we do have a lot of standards, de facto standards, specifications. You have heard all the terms. They are based upon XML. And yes, there are still DTDs around. There are still DTDs from the late 1990s that are being used for preserving data or storing data. But what we have is that a lot of the people who are supposed to use these standards, de facto standards or specifications, they don't even know what XML is. They don't even understand it. So that's where we need to step up and actually help them. So when it comes to digital preservation and taking care of things, we need to be a huge number of different skill sets participating. It's not the archivist work. Even if, yeah, I know some people in here are working at archives or have been, and the archivist has a tendency to, I'm taking care of the data, it's my data. But that doesn't work when it comes to it being digital. It doesn't even work when it comes to the papers. You have special people taking care of those parchments created early on. It's the same when it's the ones and zeros. We need to do this in cooperation. So my call out today is that we need to aid these people and support the area of digital preservation, because if we don't do it, the future won't know about us. There is already a huge gap in the data that has been collected and saved. So moving into what standards, de facto standards and specifications are. Yeah, first of all, what do we want to achieve using all these kind of things? Well, we want to move that data around. That's the thing. We want to be able to get it into the system, we want to get it out of the system, we want to move it to different places, and we actually want to archive it. And then someone actually wants to have the data. It's not a black box. Even if I know archives that are black boxes, is where you just put things and you never get it back. But that's not the thing. We have a huge number of regulations here in Europe saying that data should be reused. And how can we simplify that? Looking into my area of work, digital preservation, I know you can't read a thing on this image. Don't print it on a letter or A4. You can't read it then. It's about 5 meters long. And it's, even if it's old, Jen Riley, who created this, has made a really good map of the standards that are being used when we talk digital and digital preservation and storing information. 2 different circles showing different areas. The things looks like a fly shit on the screen on the top is different standards and where they are being used. It's a couple of years old, more than a decade. Guess what? We have more standards to use. And I think you know the saying, let's make one standard that unites them all, and which means we have 10 more standards to use. Kind of the thing that's happening here as well. And looking into the standards and the de facto standards, well, the standards are the ones that are maintained by a standardization institute, which gives its complications of getting hold of the standards. You need to pay for them and so on. We know all the problems. And then we have the de facto standards. And that's the area where I am working mostly, besides being responsible for the digital preservation at my organization. The de facto standards is the standards that everybody is using. Thus it became a de facto standard. We have the rules like the other standards. We have some easier ways of getting in contact with and proposing changes. But all these are being used, and what we need to be able to understand them are specifications. We need someone to tell us how to use a standard, because quite frankly, if you look at some of the ISO standards when it comes to records management, what the hell am I supposed to be doing? You have a lot of requirements, and you don't even know, okay, when will this happen, and what am I supposed to do? How will I be able to transfer this information to someone else? So someone needs to tell us how to use them. I've been working on, I will just say a couple of more words about that, is specifications. So a specification is a document giving the requirements and what you should be using from the standard. In the majority of cases, you have an XML schema, RNG sheet schema, or something. And what needs to be remembered by the people, us here in the room, is that it was custom about 10, 15 years ago to take that standardized schema, edit it, so you got your regulations in it, or your requirements. That's not what's being done today. Today you leave that originating schema alone, and you create schematron rules to enforce your requirements. Makes it easier if the originating schema gets an update. You need a guideline. Since I said archivists, they are not technical. They need a guideline to know how they should be using it, even if it should be a technical person who actually implements this use. And examples. And I warn you, real life examples. You can't come up with a fake one. What we are leaning on when it comes to digital preservation is the OAS reference model, Open Archival Information System reference model. And it looks like that. Don't try to understand it. Let's do it like this. I saw this image in 2009 from colleagues in US, and it's so good. I can make everybody understand the OAS reference model. I have my grocery bag. I take it in the door. That's my submission information package. I put it in my fridge, and behold, it's a really good fridge. It can store things for eternity. That's my archival information package. The thing I need to take care of for those eons. I can either take the bag as it is and put it in my fridge, or I can split things up and store eggs as where the eggs are and milk and so on, all depending on my system. And that's the thing we need to have in mind. All this is also depending on my system, who someone else has created. Or if I created myself, I need to think about that. Then a question comes for dissemination. So I need to create my dissemination information package. So either I take my bag out and give it to someone, or I take stuff out and cook a meal. And here, when you have archivists in the room, they start, ooh, no, you can't do that. You can't cook a meal. You have destroyed my information. Have I? I'm not sure. So that's the model that we are using. That's the model you need to think about, that the XML will flow around in. When it comes to the preservation itself, we use premise, so preservation metadata implementation strategies, a de facto standard, and quite frankly, the only standard for digital preservation. We don't do the digital preservation. It's all the elements you need to know about and have insight in when you do digital preservation. With the aid of premise, we can fulfill the preservation goal pyramid. Why do we do this? Why do we keep the things? And quite frankly, when things became digital, the demands on knowing that the data is still the same data has grown. Let's not go into digital signatures. That's what we do in the systems. Then we have the specifications. We need to understand what we are doing, what should be done. And I started off with this in 2006. I got my bachelor degree in computer science, so I'm not an archivist. Which some people say, you can't talk about these things because you're not an archivist. Well, I know the information, I know the data. And I wrote an essay about metadata encoding and transmission standard, METS. And they thankfully has created themselves a profile. Or you need to create a profile. You need to describe how you're going to use the standard. And I think that's one of the few that actually have that. So how am I supposed to use this standard transferring information? That led to another thing. I was part of and leading the work in Sweden to describe this for everybody. And in the final end, it became the Swedish National Archives kind of regulation of how you should transfer information in Sweden. It's being implemented in a number of systems, and you will see some of the hiccups I'm seeing as receiving these kind of information. One thing led to another. We have a number of eArcs. And that was a project started in 2014. It's 10 years anniversary this year. And that's a really strange EU project. They needed to be sustainable. They needed to do something that was not just a project and vanished, as the European projects usually do. And they built upon the Swedish specifications on how to transfer information. So, alive and kicking, still projects, time in between, what to do with the drafts or the specifications that were created. Well, you created another board, of course. So, and here in the name, you don't see anything about archiving. It's about moving data around. We have our main communication being GitHub. All the specifications are published there. You have different ways of publication, markdown and so on, but they are there. And what we really are focusing on is moving data around in an organized form. We have the information packages, the bags, which are the data files and the extra information that is being transferred. The standard METs, the current version looks like the biggest chunk of things. Version 2 will be a little bit more simplified. If I'm receiving data, it's like receiving a parcel when I'm doing that online shopping. How do I know that I got what I wanted? I need to have that receipt, knowing that I have get the files, and also knowing that the size was correct and so on. And then we have the content, what I have in my bag. And there you have numerous ways of doing it. Either we say that you need to have this kind of documentation, or you need to have information structures following this XML schema. You can do it in so many ways. It all depends on the information we are transferring. So if it comes to the publications that are quite frankly, the most common thing I hear about in this room. I need to know that I get all the files I need. I need to know where to place it in the package. I need to have the schema so I can actually validate it. A lot of things needing to play together. So I said I should show you some hurdles. It's kind of funny looking into this. My problem is that I can look at it, since I've been part of developing this, I can look at the files and really see straight away what the error is. An archivist can't do that. We are lucky if they even know what an XML editor is. Nowadays, you're even lucky if you can open a file in Internet Explorer or something. So what do we see when it comes to the XML? XML declaration, anyone? Numerous XML declarations? Or the bottom, we have a file that says it's XML. When you open it, it's kind of cute XML, I think. Or not knowing the rules of XML. File ID is of the type XML ID. Yeah, you need to know some things to do, make sure that it's correct. Or the middle example, what am I supposed to do with this? Set your agent name. Or here goes your agent to note. My comment on these are usually, I hope this gets filled with correct data when this is exported from a system. I can tell you it's not always the case. And all the different ways of writing an ID. So this is my most common thing I say, validate your XML documents. How can we get people to validate their XML documents? I need your help here. And when we look at well-formed and validation, it's not better. The first top, yeah, you see the schema is supposed to be in the same folder. No, it's in the schema folder. Or you have made all the connections, but you still haven't validated it. So we get a lot of red lines. And yes, you can see that I'm using Oxygen because I think that's the cruelest one. And on the bottom one, and here it comes just because I have been part of this. Yeah, a common thing is to not realize when a thing has been updated. People start to mix things and keep things from the first version, which has been abolished in the third version. So you get a total mix-up, and this thing of connecting with the schemas. A really recent one was, okay, looking at the XML, it's well formed, and you gave me 5 XML schemas. Well, no one has never asked me to connect those two. So we need to connect them, because we need to validate, because we are taking care of this information for the foreseeable future. We need to be able to validate it and see that it's correct. Giving namespaces, not connecting with schemas. There are a lot of schemas in use. And mixing things up. So how can we get through this? Well, validate. And what we in this room can do, besides telling everybody to validate their XML, please, I think we need those T-shirts sent around to everybody. At least the de facto standards are available on the web, easily to download and take care of. Send emails. There are addresses in email addresses to connect with people. Get your hands into it. And quite frankly, do we really need one more XML schema? Make sure that there isn't one already available. When it comes to the DILSIS board and the European specifications, we need suggestions on specifications. And quite frankly, it's better if the experts on the area, so when it comes to docbook, data, and all this, when you have a way of using it, give us suggestion of a specification and of how it should be used. Because I know a lot of things, but I'm not the one who should be writing all the specifications. Even if I have had people asking me to create that ring that unites them all. It doesn't exist. Most of these standards that we are using are on GitHub in one or another form. Use the issues, give comments, and remember, most of the people working with all these kind of things are doing it voluntarily, and hopefully their employer are supporting them. But still, say that we need to validate XML data. Another thing I've been hearing is that XML is dead. I would say it's not. It's like Mark Twain. It's an X-aggregation. JSON in all its glory is not for long-term preservation. It's for sending short things, updates. No, I can't create an API for creating the XML that you want, because I don't know the originating system. The thing with these kind of specifications is that they are supposed to be usable for all systems. We need to get the data out of the systems because we are not going to be able to store all the systems. Emulation in all its glory, no, it's not feasible or feasible. So what we need to do, what I want all of you to do is actually, no matter your gender or how you identify, put on that shiny white armor and help me. We need to be champions and show that XML is not dead, that it's not only used for publications, that it actually is a way, if it's done correctly, to save our data to the future. If an element is really good named, it's easy to understand that a name is a name is a name. I've seen examples of people creating elements called A, B, C, and how do you know what that means? Quite frankly, the people who had created that schema, when I asked them, oh, we don't know, we just took it over. So this is a common effort we need to do. We need to support the future and make sure, because if we structure our data in a good way, it's easy to reuse. People want to take advantage of the data. They want to reuse it. We need to do this together, because otherwise we are just going to be a blink in the history because our data is gone. Thank you.
Thank you very much, and thank you for tips what to put as slogans for next time's XML Prague t-shirts. We have a couple of good tips. So are there any questions over there?
Yes, tack Karin. This is an adventure or endeavor into the human psyche to make sure people understand that they are betting on the right horse. And with that, we need to make sure they have at least the sense of self-control and everything that comes with it so that they can actually understand it. And we also need to have the processes for this in the sense that, okay, it takes a lot of time to wrap your mind into the perspective that was the ones of the committee or the working group or so that was working with this for many, many, many years. And you need to understand it even before you can provide that comment on or that issue on the specification, because it's probably not the way you think it is the first time you see it, not even the 10th time. So yeah, we need to help accelerating the way to understand these specifications and standards so that we can actually work together on that. So thank you for bringing the cooperation part up there.
Thank you.
And then there is a question from Sid, I believe.
Yes, ma'am. Thank you for the presentation. I found myself taking notes of several efforts that I was not already aware of. And I thought in trade, I'd mention one that perhaps you should look at if you're not aware of. It particularly aimed at digital humanities project, the University of Victoria Endings project is aimed at teaching people building XML projects how to develop them so that it's easy on the archivist when they're done, is their actual goal. Not just so much in the XML data where their mantra is also validate, 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 you know, as Michael Spurgeon McQueen says, validate your data early and often. But also how to wrap the end product, the website, the delivery, into a method that is going to be easier on archivists in the future, and to rely on lesser technologies is the basic idea. It's very worth a read. They've really got their act together, I think. Thank you.
Yeah, and I can counter that one. Here in Europe, the national archivists have a working group, and they are looking into something they are calling archiving by design. And I think it's common, but not totally exactly the same. The big issue with archiving by design is they have still, in my opinion, not agreed upon what it means. But they are archivists, so I'm not saying anything more.
Okay, then there is a question from Lorenzo.
Hi, thank you very much for your talk. It's very inspiring. Being myself involved in creating standards for public administration, I know a bit more, and there are even more on us, like it needs to work also for archive. We have archival regulations, and now I need your help. So you said XML, I say yes. They always say PDF. What's the best argument for that?
Well, PDF has its advantages. The problem with PDF is that people still don't see information as we do. We see the information being in the elements, or quite frankly also in the attributes nowadays. And what people still see is that paper. So that means that the PDF is quite excellent for showing the paper, but how do you reuse the paper? You want to reuse the information. So it's a shift that will take a long time. Even archivists has that problem of not being able to differentiate between the paper and the information. I struggle with that all the time, because I care about the information. What you get out on the paper is the layout. And what are we supposed to preserve? Is it the paper or the data?
Okay, thank you very much again. So next speaker will have invisible presentation. Hopefully no, it will be about invisible XML.
an application of invisible XML, which Stephen will speak about later on today, in fact after my talk. This is called transparent invisible XML. And the motivation for this work was a project called the link extractor, which we built 10 years ago, we started. And this program recognizes references in legal text, so you can think of laws, treaties, court rulings, judgments, etc. There's a lot of legal material out there. And there are references in there that only consist of text. So it could be a court ruling referring to article number such and so of this or that law. And we want to enrich those documents with links so that you can actually click on the reference and then you go to that part of the other document. And this link extractor has been in use since 2015. It uses named entity recognition for all the names of laws, treaties, etc. It uses parsing expression grammars to analyze the structure of the text. And it was written in Java 8, Apache Cocoon, and XSLT2, which means by now it's technically obsolete. And several of the customers using this have said, yeah, we can't use this, it's not safe anymore or secure. And we try to show, yeah, you can still use it, there's no risk, but they wanted to upgrade it anyway. And we said, yeah, well, that would be an interesting project. So at the moment, we've started to re-implement this using Java 11 or higher, XQuery 3, XSLT3, and invisible XML. So what does the link extractor do? Here I've got a small part of Dutch text. The other text will be in English. And in number 3, I don't know why it's 231, I'm not a legal expert, but there's a link to this article number 2.14, member 1 of the BVIE. That's some kind of treaty about intellectual property. And the link extractor analyzes this part, it recognizes the link, it provides a link, and on the website of this court ruling, you will see that there's a link and it says click here if you want to see related links for this article. And then when you click it, you go to a page which tells you everything that we know about this specific article of that law, including the outgoing and the incoming links. So we have now created a whole web of links between legal documents. So that's what we don't want to do again. And we want to use invisible XML. There will be in XPath and XQuery 4 this function, fn invisible XML. It takes a grammar, which is a text specification in XML. It takes some options about how to parse. Those go into this function and it generates another function. That's the box over here. And that takes a string, just a piece of text, which it will parse. And then the output is hopefully a structured XML document indicating how the input text was parsed. It could also be a parsing error. That's why it says it's an item. It's not just an XML element with all the parsed content, it could be an error message. So how can we use XML to recognize these references? Here I have part of a report for the Council of Europe. This is from the website. It looks like a piece of text, although the slanted A here already gives something away of what's about to come. So we wish to recognize this link to Article 40 of the Statute of the Council of Europe. And this is an XML grammar rule. We now still have parsing expression grammar rules, but this is an important part of that grammar. It says that a reference is a part type, like article in this case, followed by some spaces, followed by a part ID, which is 40.a. It specifies which article we want to refer to. Some spaces, then an off thing, in this case that's off the, but it could be any number of phrases, some spaces, and then in this case a treaty. It could also be a law or something else. In this case it's a treaty, the statute of the Council of Europe. And the first part is optional from here to here. So a reference could just be a treaty if you want to refer to the whole treaty. Now here I have the part of the XML of the underlying document. So we have a paragraph, there's this text, I've marked it yellow, what we're going to recognize. Here's the grammar again, and when you feed it this part of text, when you feed that into the parser, it will create an XML tree, which I've shown here. It's a reference with a par type article 40a of the Statute of the Council of Europe. So this seems fairly easy, but now the problems start. Problem number one is that Invisible XML parses the whole input text. And that's not what we want. We only want to mark the interesting phrases or pieces of text, and everything surrounding that, which I've double dashed here, is not interesting for us. We only want to match the recognized parts and provide some extra markup so we can make links of those. So the question is, how can we ignore but also keep the surrounding text and just mark up the bits that we've recognized? Now, there's several solutions that we could provide. So one thing would be to use this funny pattern to ignore the surrounding text. This means it's not one or more occurrences of anything, which means anything goes. However, this is ambiguous because in XML there's no way to indicate the shortest such match. So this a good parse would be to just parse the whole document with this pattern, throw away all the references, and that would be very valid. So we would not recognize any of the references in the text. Also, if you would add this, and it's actually a bit more complicated than this, it obfuscates what the grammar is intended for. So ideally, we would just like to specify the parts that are interesting, that are the references, and ignore anything outside of that. So a better solution would be to tell the parser to match only fragments from the text that have actually matched, and to do so repeatedly, because there can be multiple references in the same document. So in order to do that, I added some parser options. By the way, I did this for the markup blitz parser made by Gunther Rademacher, which he integrated into BaseX. And on Thursday, I also presented my own integration into ExistDB. So you can use iXML now in both BaseX and ExistDB. And for my implementation in BaseX, I added the options multiple matches, which says you can match pieces of text and do so repeatedly. Skip unmatched words, which means all words. We can go into definition of words, but let that now. Just skip them when they're not matched. And we want to have the longest matching text fragments. So when we do that, we run into problem number 2. Because if you may have seen already that within this piece of text that should be recognized, there are XML elements. There's an emphasis element around the A. And that's a problem because the parser that's generated by Invisible XML has a string as its input. However, this is structured XML. Actually, it's not really structured XML. It's it's some text nodes, then there's an emphasis node and some more text nodes, and we want to match halfway the text node. So how are we going to do that? So one solution, which we actually did in the previous phase of the project, is to serialize the whole thing to text. So we get a serialized version of the XML document, and then to have a small XML parser in our grammar. actually, sometimes it takes up most of the grammar if you want to do it correctly. And again, this obfuscates what the grammar is intended for. It was not about parsing XML. We have perfectly capable tools for that. We only wanted to match the references. So it works, but then you have to serialize, run the link matcher, recognizer, and then to parse again. So it's also quite slow if you want to do this and you do the parsing in multiple phases. So another solution would be to throw away the XML elements and just keep the text. After all, then we just have a string of text, and we can parse that. If we use these matching options, we can get the right fragments out. But then we need to put the elements back because we don't want to have a mutilated document. We want to enrich the document. So we need to find a way to put the elements back. And the way I've done that is to make the XML structure, which is marked red over there, transparent. So the parser parses the XML document or part of it, but it doesn't see the XML elements. So that's why this is called transparent invisible XML. And in fact, if I have this rule that I showed before, then the transparent invisible XML parser will ignore these XML elements, and it will parse the text and then put in these bold XML elements, which result from the parsing using IXML. Then it will put the emphasis back, and we have an enriched document with additional XML elements. So now it's time for the demo, which is always a bit of a, I think it worked, yeah, good. So this is the BaseX client. Just to show that it works, I'll run this and go back over here. So here I have the input. It's the same piece of text with the emphasis. Here I've got the grammar. This is my reference rule. This is a part type. In this case, it's only article. The actual grammar is a lot more complicated than this. There's a part ID, which is a number optionally followed by a dot and A to Z. No emphasis there. And then we have off, which can be a comma or an off with an optional space and the. These are spaces, and the treaty for the moment is just the Statute of the Council of Europe. So if I run this, this is the output, and you can see indeed we have recognized the reference, part type, part ID, the treaty, Statute of the Council of Europe, and here ends our reference. So we have successfully recognized this. Now, of course, we want to recognize more treaties, so here I've put in a lot more treaties of the Council of Europe. There are like 267, no, a bit less, but so I can run that as well. And now you'll see that we also have recognized as a treaty the General Agreement on Privileges and Immunities of the Council of Europe, which is the second treaty of the Council of Europe. However, we don't know which treaties these are. And I think that's what I'm doing here. So the same input text, same grammar. However, treaty can now be any of these. Oh, it's 224, actually it's a bit more treaties. So I've got a rule for all these treaties. And then a treaty can be any one of those. It should be, that's up here, yeah. So this works, but you can imagine if you want to have all the regulations that we should recognize, it becomes very long. And I'm not going to run this because it will actually crash BaseX. So what can we do about that? Well, we can, instead of using IXML for recognition of fixed text strings, I'm using named entity recognition. So I've also made a named entity recognition function in BaseX. The code is online. There's a link in the paper in the proceedings. And then I have a different kind of grammar, which says the CETS 224 is this text. And you can specify multiple strings separated by tabs, etc. That's explained in the paper in the proceedings. So I've shortened it a bit here. I've left out a couple of treaties. And then these are the options for named entity recognition. I'm not going to go into that. It's sort of explained in the paper and on the GitHub repository. And then I have this named entity recognition function, and that will give me a treaty, and it has an ID of ETS001, like specified here, and ETS002. And this is much faster. Actually, the previous slide where I had this long list, it will crash base X, because when I put in 267,000 titles of laws and treaties, well, it doesn't work because I tried it with 10,000 and I need 8 gigabytes of heap space, which means to put all these names in there would require more than 200 gigabytes of RAM. And I haven't found a good laptop with that amount of RAM. So let's go back quickly to the presentation. So yeah, I skipped this because I'm running out of time, but this is basically what I said. So this is the function for named entity recognition. It's very similar to the invisible XML function. So you have a grammar, which looks a bit different. You have options, and it yields a function from a node, because we are now parsing XML documents, and it gives a node, which is the XML structure that comes out. We've had this. So now we run into the third problem. I've recognized these treaties marked in yellow over here, which is great, because I have this grammar rule specifying that we want to find a treaty. But I just made all XML elements transparent. So the XML parser will totally miss these treaty elements, which I did on purpose, because I don't want it to see these XML elements that may be in the document. So yeah, we've shot ourselves in the foot, so to say. How can we solve that? Well, an easy solution, which I've implemented at the moment, is to surround the treaty elements, or the content of the treaty elements, by special markers. They should be a bit more complex than 3 square brackets, but that's what I used for the example. And then a treaty, so here I have a treaty, and it's specified by this rule. It can be, it is the beginning marker, some text, and the end marker. And as you see, this must be the shortest match, which we can't guarantee at all. But it works sometimes. Maybe it will work now. And then this will be our pipeline. We have an input. We do named entity recognition. Then we have a step to mark the treaties. That's just an XSLT. We give that to the IXML parser, and then we unmark the treaties. So we remove those red markers again. That works. But actually, what's even better is to use what I call pre-parsed non-terminals, which means that we make only some XML elements in the input transparent, but other XML elements can be accepted as part of the IXML grammar. And that requires a modification of IXML, which I show here. So here I have, I thought let's use pointy brackets, because we use those anyway in XML. And if you use this notation, the parser will parse everything as usual, but it will see that at some point in the input there's a treaty element. And it will pretend that this treaty element from the beginning to the end of the element is a non-terminal. So it's like it's pre-parsed. We already did that in a previous step. And now it says, okay, this is pre-parsed, it's non-terminal, and it skips the whole content of the treaty, including text and possible XML elements, and then it will continue parsing after that. Here's a picture showing that. Here's a reference. We have this pre-parsed non-terminal at the end, the treaty. Par type matches with article. Then we have 40 with some transparent element A, then we have an of the, and this treaty element, actually I told the grammar to recognize that as a treaty, non-terminal, and everything inside it gets parsed. This is still work in progress to add this to the XML parser. I'm working on it because we need it for our project. I think I can have it ready in August or September, depending on what other things I have to do. And I think the important part of this is that transparent XML can now be used to either ignore or accept XML elements, which means we can use invisible XML to enrich XML documents, not just plain text. And there's a lot of XML documents out there, well, I wouldn't say much more than just plain text, but we really like those documents, and until now, invisible XML could not really enrich those, but with this addition, it can. So last demo. Did I do that? Here I have the demo with the markers. So it's a lot of code, but here I have a marked treatise. Here you can see the special markers that I put around it. Here's the unmarker style sheet. Then we have the XML grammar. And here's the pipeline I showed earlier. And then when I run this, indeed, I get a reference of this treaty. It's just like nothing has happened to the treaty. It's still there, but now it's part of the reference. It has been recognized. But this is with the markers. This is not yet with the pre-parsed non-terminals. Sorry. So, having said that, I'm right on time. Thank you. Thanks to Gunther Rademacher, who really helped me out with a lot of questions I had about his markup blitz parser. Thanks to Stephen and all the other people involved in Invisible XML. Thanks to the XML Prague organizers and you, the audience. The code is on GitHub and links are in the proceedings, so I'm not going to show them here. Thank you.
Thank you very much, Nico. It was been really interesting. So there is a question from Stephen and Norm, but Norm has been quicker, so Norm first, you second.
Excuse me. Thank you, Nico. That was really very interesting. There's half a dozen ideas in there I want to explore, and nobody wants to listen to us chat for the rest of the day. So one quick question. The obvious concern that occurs to me is if you take the markup out, the transparent markup out, and your grammar adds more markup, and you put the transparent markup back, how do you address the possibility of introducing overlap?
So that is in the paper in the conference proceedings. I use a technique that I introduced several years ago called a separated markup API for XML, or SMAX, which separates the text content of the document from the markup. It remembers the character positions. You can even change those when you insert or delete something. Then after whatever you want to do on the text content of the document, it puts the XML structure back. But that's explained more fully in the paper and on the website of SMAX. So I have several strategies to balance the tree again, etc.
Okay, so next question from Stephen.
Well, it's more a remark. You said it has to be the shortest match at one point.
Yes.
But if you make that a not closed square bracket, then you get the shortest match.
Thank you. Okay, I'm going to change that immediately.
So it's time for additional coding. Sorry, question over there from
Am I doing this? Sorry. It's this thing.
Yeah, so you will do it. So just use
Okay. Yeah.
Another question?
Thanks. I got very excited because this is what I do with a more traditional, classical, regular expression machine. And so I'm interested, is this reasonably faster than the regular expression approach using iXML?
Yeah, when we started this in 2013, someone had already made a program using regular expressions to recognize legal references. He compiled those regular expressions from parts, and the regular expression went up to 5 or 6 pages. It became very slow, and also there was a bug in it that no one could fix. And I'm aware of several initiatives like the Building on ECLI initiative in the European Union, and they all try to use regular expressions, then they found out it doesn't work, so we need some kind of subroutine thingy in regular expressions, and that's a lot of work to program that, but you can use parsing expression grammars for that. Basically, parsing expression grammars are an extension to regular expressions.
One last question.
Hi, thanks. I was just wondering whether you had considered using invisible XML pragmas as a way to extend the markup in your grammar rather than the angle brackets so that it remains compliant with the specification?
I haven't considered that, no.
Cool.
I need to think about that. Thank you.
Thank you.
Okay, so I don't see more questions, so thank you very much again. So XML is definitely not dead, but maybe it became invisible. So next speaker is Stephen Pemberton, and he will talk about invisible XML.
Okay, thank you very much. So before I start talking about IXML, I just wanted to say something about me that you might not know. At university, my tutor was Dick Grimsdale, who built the world's first transistorized computer, and his tutor was Alan Turing. So that makes me a grand tutee of Alan Turing. Entirely coincidentally, I worked later in Turing's old department in Manchester on the 5th computer in the series of computers that Turing worked on. Turing worked on 1, 2, and 3 before he died. The reason I mention this is that yesterday was the 70th anniversary of Turing's death. Suicide because he'd been castrated, chemically castrated, because he was gay, which at that time was illegal in Britain, and he was forcibly injected with estrogen. He grew breasts and got depressed and killed himself. So I just thought it would be nice to just remember Turing, that we actually owe, a person that we actually owe so much to. Anyway, now to get on to IXML and the talk. So as you've just seen, IXML takes a textual document where normally the structure is implicit, that we can see just by looking at it, and it turns it into an equivalent structured document where the structure has been made explicit. So as a very simple example, you've got text, which is a date, and so we provide a description of that, which says it's a day, a slash, a month, and a year, with definitions for day, month, and year. And then we put that through IXML, and we get a structured document, an XML document, where we have the day, month, and year elements. Now, the question is it possible to round trip, in the general case, round trip IXML? That is to say, is it possible to produce the document that produced the structured document? Now, as you will shortly see, there are problems about round-tripping IXML because input characters may be added in the process. Input characters may be deleted in the process. And some nodes may be serialized as attributes rather than elements, which reorders the content. And that's what I'm going to be dealing with. Okay, so it's impossible in general to create a character-perfect version of the input that's gone through IXML. Let me just make this slightly smaller. But what I've done is redefined exactly what we mean by round-tripping in this case. We're going to create an input that would produce exactly the same output. So if you look at it this way, here we've got the original text document T that's gone through IXML and produced the structured document. What we want to do is round trip to a different document, but a sort of equivalent document that would then go through IXML and produce the same structured version at the end. So that's the aim of the round tripping in this case. So it's not to get a character perfect version, but to get an equivalent version of the input that will produce the same output. So an example is if you're processing a programming language with IXML, then it might have lots of spurious spaces, as it were, comments and stuff, which you might delete from the input when producing the structured version. But if we round trip it, we'll get a program out that does the same thing. It just doesn't have all that extra space and all those comments. So let me just describe the problem space then. So in the case that we've already seen, if we take 30.06.2024, then what you see is that all the characters in the input are still in the output. All we've done actually is just added tags around the input to show what the structure is. So if that's all we do, if nothing is added, nothing deleted, and no attributes are used, then we can just concatenate all the text nodes, and we've got the original document. So in that case, it's perfectly possible and easy to round trip IXML, and that is a choice that you could make when designing an IXML grammar. You could say, well, I want to round trip this perfectly, so I won't delete any single character from the input, and I will just add the structure. So that is a choice, but that's not the choice that you always get to make. In the case of the deletions here, the same grammar, but in the case of the dates, those slashes don't actually have any semantic meaning. They're just there syntactically to separate the different parts. So you can delete them, and then they don't turn up in the structured version. So now we can no longer just concatenate the text nodes to get our result. Similarly, insertions. For instance, if our input format has got dates with only 2 characters, like 30.06.24, but you want in your output version to have the full year, 2024, then you can show that in the year there. You can show that by adding 20 so that the output now has 2024. And again, we can't get our input document because we've added characters to the output. And finally, with attributes, you can specify that a particular element in the earlier version is actually to be serialized as an attribute. So if we put an @ before year there, then what we get is that the date has a year attribute instead of an element, and of course now the input has been reordered. So how do we deal with these problems? So in earlier papers about IXML, I've suggested several possible ways of doing it. This is yet another way, and this one I've actually implemented. So the approach is to transform that input grammar that we have for IXML into a different IXML grammar that recognizes the serializations that we're producing from the IXML. Then we can just use IXML to parse the XML, get more or less the same parse tree out, and serialize that back to text. So that is the aim, is to transform grammars into new grammars that do the round tripping for us. So, as an example, if we take the very simple list of the date grammars with no additions or deletions, so that's the grammar at the top. What we do is we add elements, strings into that grammar that represent the serialization as XML. So for a date has a starting and an ending date tag, and we don't want those to come out in our output, so they're deleted with minus in front of it. Similarly for day, similarly for month, similarly for year, and the digit rule isn't an element anyway. So if we use that on the XML, if we use this new grammar on the XML that was the serialization of the date, then what we get out is this thing. I'll talk about why it's got date tags around it, why we haven't made that invisible shortly. But in other words, we've perfectly round-tripped it by parsing the XML. Now, let's take the non-simple cases. So insertions, well, the only thing that's changed there deletions, they should say, actually, I'm sorry. The only thing that's changed here is that we're deleting the slashes in the rule for date. So when we transform this, we add our elements front and rear, and we do insertions of the characters that have been deleted. And so, and finally, I didn't give an example of that being used. And finally, if a rule has got an addition, such as year, well, then we just delete that in the transformed rule, which will give us back our original input. So those are all the easy cases. We just parse the XML and add stuff where we've deleted it and delete stuff where we've added it. And I think I summarize that here, yeah. So non-hidden rules get hidden, but we add the tags at the beginning and the end. Hidden rules remain hidden, and no tags are recognized, of course. And in alternatives, non-terminals remain the same, regular terminals stay the same, deleted terminals become inserted terminals, and inserted terminals become deleted. So it's of course, we're just doing the opposite of what we did on, with the original grammar. So now the only problem that now remains is what to do with attributes. And so here, this is the case from I've showed earlier, that we've got the attribute year, and so the output there gives the year as an attribute on the date. So how do we recognize this? Well, we can recognize this structure because we just move year into the position in the serialization where it's going to turn up, and we recognize year as year equals and a quote, and then whatever the construction was for that attribute. However, that correctly recognizes the XML, but when it produces, what it produces on output is the 24 in the wrong place, because of course we've moved the year up to the front of the element, and so that's where it's turned up. So in other words, we've recognized it, but it turns up in the wrong place in the round tripping. So what we need to do is deal with that by providing a mechanism for putting stuff that's been moved to the front of the element back to the right place in the element. So how attributes work in IXML is that the grammar explicitly identifies the part of the input that's going to end up as an attribute, but implicitly identifies the place where that attribute is going to be serialized, because it's just going to be on the nearest element above that point. So it just goes up the tree, as it were, finds the element, and adds the attribute there on serialization. It's done in two phases. When serializing an element, when having produced the opening tag of an element, it then goes through the structure of the element looking for other nodes that have to be serialized as an attribute, serializes them as the attribute, and then goes through the tree again to serialize the children elements. So what we have to do then is to reverse this process, is we have to recognize the attribute at its implicit position in the XML and explicitly identify in the grammar where that thing should be serialized in our round tripping. So we can do this by defining two extra marks. The marks in the grammar help you with how serialization works. So one indicates that the attribute as parsed shouldn't be serialized at that position, and the other one to indicate the place where the attribute should be serialized. Now, this is very similar to how insertions and deletions work in IXML, because a minus before a string means parse the string but serialize nothing, and a plus means parse nothing but serialize the string. Now, unfortunately, minus has already been taken for another use, a similar use but different in IXML, but plus is free, the same meaning, just to say parse nothing but serialize the non-terminal. So we have to pick another mark, and fairly randomly I chose the asterisk. So the asterisk means parse this thing in the input, but do not serialize it here. And then later, I've got plus year, which means look for the thing called year earlier in the input, well, actually higher in the tree, with this name that's been marked with a star, and serialize it at this point. So if I take this grammar, then that now does correctly produce the output as we'd expected. So we've now correctly round-tripped XML serialization with attributes. Now, I should note that I haven't added these things to the IXML language. These new marks are internal only to the internal form of the grammar. So I haven't changed how the IXML language is externally. I've only changed how the IXML processor works by adding those marks internally. But I will talk about that shortly. Now, within the IXML community, we talk about two different sorts of grammars, strict and permissive. If your input for IXML is not necessarily correct, then you'll have to have a very strict grammar that checks for the correctness. So for instance, for dates, if it might not be correct, then you're going to have to check a month, not as 2 digits, but as an optional 0 followed by a single digit, or 10 or 11 or 12. Those are the only possible values for a month. Another example is IXML itself, which is described in IXML. The grammar has to be very strict to check that the input is correct. On the other hand, if you know that the input is correct and you're only recognizing stuff there, you're not checking that the input's correct, then you can be much laxer in what you expect, and what you process. So for instance, if you only try to recognize dates and you know that they're all correct, then DD, 2 digits, is just a perfectly good representation for a month, because a month is just 2 digits. So even though this would recognize 13 or 99 as a month number, we don't have to worry about it because it will never occur. So we call this a permissive, these permissive grammars that recognize rather than check the input. Now, the nice thing is we're sure that the XML that we're going to be processing is correct because we've produced it. We know it's correct. There are lots of things we don't have to check for. So that means that the transformations that we write are much easier to write because we're not having to check for a lot of stuff. And a particular example is, will the short form of an empty element occur? Well, to know if that's going to happen, you'd have to do a processing of the grammar to find out if its content could be empty. But in fact, we don't have to do that because we can always supply an alternative that recognizes the short form for an empty element. And if it occurs, it matches and we're fine. But if it never occurs, it never matches and we're also fine. So it means that we don't have to do lots of processing on the grammar to find out if an element could be empty or not. Because if it can, and we can recognize it. And if it can't, well, we never have to recognize it, but we can still have the rule there. So that makes life easier in the transformations. Now, I should just mention that IXML has a bunch of extensions for making grammars easier to read, such as options, repetitions, grouping. And as the specification points out, specification of IXML, these extensions add expressiveness for the author, but they don't add any recognition power. And that the specification shows you that all these things can just be converted into equivalent IXML grammars, which are just harder to read. What that means is that round tripping is also much easier because we don't have to take these extensions into account. We can either assume that those transformations into the simpler version have already been done, or we can do it ourselves. But it means that we only have to transform simple grammar rules and we don't have to worry about things like options. Now, IXML, in regular IXML processing, it's possible that the grammar can be matched in more than one way against the input. That might be a mistake on the grammar writer's behalf, or it may be that the input is actually ambiguous. So XML processing demands that the processor only produces one of the possible serializations, that there might be many different versions of the serialization possible, but it's required to add an indication that the result that you've got is ambiguous. In other words, that this could have been interpreted in a different way. That is that the serialization is only one of the possible interpretations of the input. Now, similarly, round tripping it can also be ambiguous. In fact, and ambiguity in this case means the string that we've produced is only one of the possible strings that could have produced the structured version. And in fact, that many inputs that many input grammars, XML grammars, that are not ambiguous, and serializations that are not ambiguous, on round tripping can be ambiguous, funnily enough. And an example of that is, for instance, if you're allowed multiple spaces between items on the input, but that you delete the multiple spaces, which you're deleting all white space, then on round tripping, it would be perfectly acceptable to insert any number of spaces back into the string. And so that's why it's ambiguous, because there are lots of possible inputs that could produce this same output. In this case, the solution is to produce the smallest string. So if you've got a plus, then just produce one of those things, and if you've got a star, produce 0 of them. And similarly for optionality, if you delete a thing that was optional on the input, then it's not in the structured version anymore. So the question is, should you insert it back into the round tripping? Well, the choice is yours, but probably the preferable solution is just not to add it and produce the shortest string that could have produced the structured version. So ambiguity in XML is marked by putting an extra attribute on the root element, and that's why it's necessary to retain the root element on the round tripping. The output is anyway flat XML, because it is XML, so we're actually only producing XML on the output, but we also need somewhere to add this extra information. Some implementations on serialization might produce nice indented elements. You could add this to the transformation to recognize pretty printing white space. But the problem is that might add extra ambiguity, because there might actually be space characters in the output that have not been added by the system. So in general, it's better to round trip XML without added white space, without added pretty printing, to avoid that problem. So future work, good. I'm in good time. Future work. So what I'm describing now is all work in progress. All the examples are actual output from the processing. But I want to talk about some possible results of this. And there's at least one thing which I think might shock you, so I want to make sure that you're sitting well, because I don't want any problems with people injuring themselves when they fall off the chair. The serialization and transformation are very, very similar. If you look at the code for the original serialization and the code for transforming grammars, they look very, very similar. And it's not surprising, really, because both of them are walking a tree, sort of fairly similar looking trees, and one outputs the serialization and the other outputs a grammar that recognizes that serialization. So they're almost isomorphic, which one day raised a question to me. What would happen if I took the transformed grammar and transformed it a second time? What would it produce? And the answer is it round trips the round trip, fairly obviously, because that's what the transformation does, round trips. In other words, it produces the serialization of the string that we produced. In other words, it serializes the input as XML, sorry. Now, this already works in basic cases. So, for instance, that original case of the date, if I round-tripped it twice, then I get this thing out. Now, it's got ampersand LTs in it because I'm outputting XML, but if I expand those ampersand LTs, what you see is that I get this thing out. In other words, I've serialized the original input as XML, but without having to worry about elements or attributes or anything. It's all sort of happened from the grammar itself. So this is what the process now looks like. We've got our original document T, which has gone through IXML to produce our structured document. We've transformed G into G dash here, which produces an equivalent document, but not necessarily exactly the same. But if we transform G twice and take that document, then we get back to our original structured document as well. So in other words, it's really round tripping in the full sense of the word. The corollary of this is that I could now greatly simplify the IXML processor because I don't have to serialize things like elements anymore because I've produced a grammar that does the serialization for me. So I can now do serialization by twice transforming my input grammar, and I get the same result out with some minor tweaks. So transformations at the moment are only partially isomorphic because at the moment there's no reverse operation for the new star mark that I've introduced. But if I did, that new mark would say recognize nothing but serialize the rule with this name from later in the parse. So the second corollary is that the IXML processor is now in some way completely unbound from XML because it could be used to produce other serializations in a fairly straightforward way. All I have to do is write the transformation from the inputs to whatever serialization I wanted, and I've made my life as an implementer of IXML much easier. Of course, I've added a few things to IXML internally. You might want to make those then available to the user of IXML, and there are some marks then that would need to be added to the language. Amongst those are the asterisk, although you might not use an asterisk, but that would need discussion, which says parse and don't serialize. And then we'd need another mark that says parse nothing but serialize a node from elsewhere in the tree, and that clearly would need to be generalized from the one that's presented here where it had a very specific use. And my feeling is that it would be handy as well to have a mark that says flatten the node. In fact, my transformations would be much easier if I could just say output this node as if it were an attribute. But not necessarily as an attribute, but as if it were the content of an attribute. In other words, getting rid of all the structure and only outputting the terminal characters. So my conclusions are, contrary to some people's expectations, it is possible to round trip IXML as long as you suitably define what you mean by round tripping, and you have to slightly adapt IXML serialization. The technique is very simple, it's very little code, and it actually allows the IXML processor in principle to be simplified and in some senses generalized as well. And an added advantage is that with some work that still has to be done, the entire process is completely reversible. And a reminder, Declarative Amsterdam is in November and the call for papers are open. All right, thank you.
Thank you very much, Stephen. And we have time for questions, so there.
Thank you for your talk. Very interesting indeed. If you would introduce this new operator, the asterisk you chose here, would that help in serializing attributes in a specific order? Could that help in that?
Would it help specific?
Yeah, so because you can now would then be able to define, like, here's year, here's...
Well, because of permissiveness, it's actually very easy to recognize attributes in whatever order they are, because...
It's about the serialization.
You can just list them all and set an asterisk, and you'll never have more than one. So if you had 3 attributes, A, B, and C, and you don't know what order they are, you can just say A or B or C repeated as many times, so asterisk, and that recognizes them in any order. And of course, that officially recognizes that you could have more than one A attribute, but that will never happen, so you don't have to worry about it. So that's part of the permissiveness.
Follow-up. It was about the serialized, the outputted XML document, that you could have the attributes there in a specific order.
Yeah. Well, I mean, currently that happens, that you get the attributes in a specific order, and that's the order that they actually occur in the grammar.
Okay.
Because, yeah,
Okay.
so that happens
It wouldn't
anyway.
add anything.
So I have more freedom in that case as well.
Okay. George?
Hi. Because what you obtain is a structure, did you consider for the inverse transformation to generate maybe a style, an XSLT script or an XQuery to obtain the text back? So you have one transformation, right, that gets to a structured format.
Well, I know somebody is doing that in the
so the inverse may be an XSLT script or an XQuery that you can generate from that grammar, maybe.
Somebody is presenting something at Balissage on exactly this.
Last question.
Hi, thank you. Something came to mind during this presentation and the previous one, where we have seen patterns for date, patterns for linking to treaties, number, date, of the, and so on. Does it work with multiple languages where the pattern would be different, or with placeholders, because the date might not be digital, might be written out, might be in a different order, and so on?
Well, so I treat this in one of my IXML tutorials. I mean, if you can recognize it as a human, how it's represented, then you can just provide a rule for both forms, and IXML will recognize, just as you can, which one it is. On the other hand, for instance, if you don't know whether it's an American style address or a European style address, where the Americans put the month first for some reason, then in lots of cases it's not ambiguous, because if it says 12/31/24, then you know that's an American address, and if it says 31/12, then you know it's a European address. But if it says 12/12/24, then you don't know if it's a European or well, in that case, it's, let's say 11/12/24, then you don't know whether it's a European or an American date. And that is one of the cases where you would get a warning that it's ambiguous. And it would even be able to point you to the element that says, well, this is ambiguous. I've given you one of the possible interpretations, but there are other possible ones. So you can do it, and if you can recognize it as a human unambiguously, then so can IXML. And if you can't, as a human, recognize it unambiguously, then neither can IXML. I didn't hear you. Yeah, all right.
Okay, thank you, Stephen.
Thank
I
you.
suggest if there are more questions, you can just talk with Stephen during the coffee break. So thank you again, Stephen. And yeah, there is coffee break, and we will meet here again back in 20 minutes. Okay, so as you already know, Adam unfortunately cannot be here with us because he has COVID, but he was able to do the presentation remotely. So welcome, Adam, and stage is yours.
Hi, thanks, Jyrke. So, sorry, can't be there today. Unfortunately, I recently tested positive for COVID. Rather sadly, this is the first XML Prague conference I think I've missed since 2005. So by that, I can only assume that it's a pretty good conference, if it's only COVID that's managed to keep me away. So I won't go through all of this, but I'm probably best known for my work on ExistDB, which is a native open source XML database. I've been contributing to that for about 19 years. And a while ago, Eric Siegel and myself also wrote a book about it, although I might be better known for turning up at all the conferences, even this one virtually, apparently. I'd also like to say a big thank you to everyone that sent me some very nice messages and photos during the conference. I'm very sad that I can't be there, and I miss you all, of course. So let's crack on. So what's in a title? There's a 2.0 in the title of this paper, but what does it refer to? So let's figure that out. All right, so it seems like only yesterday. Embarrassingly, this was a rather long time ago, about 12 years now. And what I've concluded is the video quality was much worse 12 years ago. And we all seem to have been wearing suits, which I guess that was pre-COVID. And things have relaxed since then. So version 1 was the paper that we delivered in 2012 at XML Prague. I never really intended for version 2 to take so long, but there are lots of interesting things out there to study, and somehow time has passed me by. So the REST XQ standard was released at about the same time the original paper was published, and it was aimed as a formalization of the ideas set out in the paper. Some 12 years have passed since then. So unfortunately, the new paper in the proceedings of this conference is some 34 pages. Please forgive me. In 2012, REST was already well established, and there isn't been a lot of innovation in REST specifically since then. There have been some enhancements in HTTP, but these are mostly about transfer encoding. Most innovations related to REST XQ have actually come from feedback from users and vendors making practical extensions to REST XQ. I'd particularly like to thank BaseX and Christian Grun from BaseX for their excellent work in this area, and that has informed part of the literature review of our paper. So we posed the question in the paper, is REST XQ 1.0 still fit for purpose? And spoilers alert, I'm afraid, but the answer is yes, it is still fit for purpose, but we would like to propose some enhancements. This paper is not a standard for REST XQ2. It is simply a review of the landscape and a set of proposals for things that might make up REST XQ2. I don't think it would be fair for me just to write a standard as one individual and put it out there and claim it's a standard. I think we need some collaboration on this from other interested parties. So REST XQ2 proposals build on REST XQ1. Some of you may not be familiar with that, so we better make sure we have a basic understanding of REST XQ1 first. So one moment. Okay. So the key thing here is really that you may have a client and a server, and they are not directly coupled through shared state. That is to say that the server does not have to track the active clients that are connected to it. Doing so would take up extra memory and CPU on the server. So REST helps us avoid those use of extra resources, which means that we can more easily scale web applications, and also that a client could connect to any server in a potential pool. So if you had a load balancer with multiple servers behind it, because the server doesn't have to track the state of the client, you can have the client connect to any server and receive the same response. So this is quite advantageous. And REST XQ is built on RESTful principles. REST itself is built on top of HTTP. This is an example of a simple HTTP request and response. Like all good early internet protocols, these things are just plain text, which is rather lovely because you can, if you want to, open a terminal, telnet to a server and just start typing in this protocol and the server will respond to you. Although I would add that HTTP 2 and 3 have added a binary encoding over the top of this, but the semantics remain exactly the same. So we're going to talk quite a lot about REST and HTTP in the remainder of the talk, so hopefully that has given you an idea what this looks like. Okay. So REST XQ allows you to write APIs and applications for the web in my favorite programming language, which is XQuery. REST XQ really defines how to route HTTP requests to an XQuery function, which is then executed, and subsequently how to turn the result of that function into a HTTP response. REST XQ appears to have been fairly successful within its domain. There are 5 known implementations at the moment: ExistDB, BaseX, MarkLogic, Elemental, and FusionDB. Interestingly, those are all XML databases. However, there is nothing to stop anybody implementing REST XQ for any XQuery processor. And it would be interesting, perhaps, if somebody wanted to do an implementation with Saxon. Okay. So the main concepts in REST XQ1, the visible part that the user or developer really interact with are the annotations. You add these to your XQuery functions to describe how they should receive HTTP requests and send out HTTP responses. When we add these annotations to an XQuery function, according to REST XQ, these functions are then known as resource functions. This differentiates them from normal XQuery functions. And I shamelessly stole that naming, I'm afraid, from the JAX RS, which is a Java standard for RESTful web services in Java. Okay, there are 2 types of annotation. Constraints describe requirements that must be met. So any function, any resource function that has a constraint annotation will only be executed if that annotation is matched exactly on the HTTP request, whereas parameter annotations are always optional, and they are simply used to extract additional information from the HTTP request, which may or may not be present. They're not involved in matching the HTTP request to the resource function. REST XQ, for the most part, just follows the serialization rules set out in the W3C XQuery serialization spec. It adds a couple of additional pieces of information about how the output of the function should be wired to those. But for the most part, you can just think of it as the W3C XQuery serialization spec. And the XPath utility functions are so few and so simple, I don't think we'll actually discuss them further today. So this is the REST XQ processing model. On the top left, we have a user or a web application. It talks to a web server. The web server has a registry of resource functions. And the REST XQ implementation is responsible for matching the HTTP request to the resource function. And that's done by examining the annotations on the XQuery function. Once it matches a resource function, the resource function is executed. The results of the resource function, which is a XDM type, are serialized according to the output annotations. The output annotations are really just annotations which follow the XQuery serialization spec. And then that is serialized to the HTTP response, and the web server sends it back to the client. Hopefully, that's fairly straightforward. Okay. It's very hard for me to gauge people's puzzled looks or not, so I'm just going to plow ahead, I'm afraid. If anybody doesn't understand anything really crucial, please shout and hope they'll hear you. All right. So we're going to look at some examples of REST XQ1. If you understand a bit of XQuery, which I'm going to assume you all do, this is probably the quickest way to gain an understanding of how REST XQ works. So this is not any sort of magnum opus, obviously. Line 8 here basically annotates this XQuery function with a REST XQ annotation, which tells an implementation that should it receive a HTTP request where the URI path is /hello, it should execute this function, serialize the result, and send it back to the client as the HTTP response. Okay. There are some default rules built into REST XQ, so this will generate a HTTP 200 OK response with a application XML content type with the XML as the body of the response. So this is about the simplest REST XQ function I could think of. And hopefully that's fairly straightforward. Okay. Most interestingly, with the path annotation, and I should say this %rest:path on line 8 is path annotation, is that we can add URI templates. So the purpose of a URI template is to allow the developer to extract part of the URI into a function, into a parameter of their resource function. So this path on line 2 has 2 URI templates, which capture 2 segments, I should say, of the URI path. And it will take those values and it will attempt to convert them, because a URI is just a string as far as the implementation is concerned. It would attempt to convert them into the types that are specified on the XQuery function parameters. So assuming that this matches the URI path, it will take the category URI template, the value that would be there in the URI, convert it into a string, XS string even, and set it as the $category parameter. And the $PID URI template, it will extract that string, but as the function parameter type is set to XS integer, it will attempt to convert it into an XS integer before injecting it into the $PID parameter. We can then use these URI segments, which are injected in our parameters within our XQuery, and we see that on line 5, where we go and look up some product from some sort of collection based on its category and PID product ID. And at the bottom there, there's an example of a URI path that would match. And so $category would be hats, and $PID would be 5645 once they're extracted from the URI path. Okay. As well as path annotations, there are a number of other annotations. The method annotations are used to, again, these are constraints, so these must match the incoming HTTP request. They're used to constrain a function, effectively, to specific HTTP methods. So the last example we saw, because it had no method annotations, this will match any HTTP request for that URI path. In this example, we constrain that further to say that this should only match HTTP GET requests. We can see that annotation on line 2 of the code example. REST XQ 1 only supported the methods that were defined in HTTP 1.1, which perhaps is a little bit limiting these days, as other methods have been developed for things like WebDAV or document patching and various other needs. And that's one of the things that we'll look at for REST XQ2 shortly. So this example is exactly the same, in fact, as the last one, apart from it's constrained to a GET request. We can add as many of these method annotations to a single function as we want. So we could add %REST_GET and %REST_HEAD if we wanted, or any of them really. However, a resource function can only ever match a single path, which I think I missed from this previous one. Yes, a path can only match, you can only have one path annotation per resource function. That is an intentional limitation that we put in the specification of 1.0 to try and make people write simple functions rather than writing one giant function that does lots of different things. So that's me imposing a certain style onto people's programming. And you may or may not agree with that. Okay. Quite an important thing in REST and less specifically HTTP is content negotiation. So if you have a client and you have a server and you have some resources, or as we think of them, documents, that you want to exchange, how do you know that the client can accept the document types that the server has, or vice versa? Can the server store or process the document types that are being sent from the client? This is called content negotiation, and it really makes use of two HTTP headers. The accept header, which describes what the client will accept from the server, and the content type header, which describes the content sent from the client or the content returned from the server. So we have two annotations in REST XQ to help with this. We have the consumes annotation, and this is matched. So if the client wants to send a resource to the server or a document to the server can describe a function that will consume that document type. So the client would send the document with a content type header of perhaps application XML, and we have a consumes annotation on line 4, which says this function is restricted to only processing put requests for the path/catalog something/project where the client has sent a resource that has the content type application XML. Okay, so if the client sends some other type of content, application JSON perhaps, this function will not be fired. This only fires for the described content types in the consumes annotation. This is quite useful because we don't want to potentially just store any old document that the client sends us. We want to know what its type is. We also use that typing information from the consumes annotation to do some automatic type conversion. And there's a set of rules for this set out in REST XQ. But in this instance, because the consumes annotation specifies an XML type, in fact, it specifies two possible XML types, and the REST XQ spec says if it's an XML type, we must try to parse it as XML. We can inject that value into our function, $new_product parameter, as a document node. So we don't get given a string of XML, we get given an actual XDM type of the document. This is very useful because we can then use XPath and XQuery on the XML that the client has sent rather than having to go and parse it first. Okay, so I'm just checking my time. Okay. At the other end of the spectrum, we have the produces annotation. The produces annotation is another constraint, but it's diametrically opposed to the consumes annotation. The produces annotation describes the output media type that the function will produce. It does not, however, describe the serialization of the function. So the produces annotation is a constraint on matching against the HTTP request. So this is effectively saying this function will produce something with the media type application XHTML plus XML. For this to match a HTTP request from the client must have sent an accept header which describes that the client accepts application XHTML XML. If the client has not sent an accept header declaring that they accept application XHTML XML, this function will not be executed in response to the request. This allows us to write different functions for different types of content that we wish to produce for different clients. And again, we've intentionally limited the scope of how these things can be used so that people write one function ideally per API endpoint rather than writing one function that tries to do everything. That's quite different to other XQuery frameworks for handling HTTP, where they quite often just give you access to the entire HTTP request, and you're left to write spaghetti code in one large function that sort of deals with breaking it out and deciding what to do. So this takes care of a lot of the routing for you in REST XQ. The interesting thing here also is line 4, the output method serialization annotation. As I mentioned before, there's a W3C standard called XQuery and XSLT serialization. That standard sets out a number of things, but in the standard, the expression of the serialization parameters is either XML, or I think there is also a map representation now. In REST XQ, we've taken exactly the same semantics, but said that you can use these as annotations. So anything that's in the serialization spec can also be expressed as an annotation on a function. And that allows us to control the serialization at a perf resource function level. Okay. So those were the constraint annotations previously that restrict which function will be executed depending on the HTTP request that is received from the client. And as well as those, we have a number of parameter annotations which allow us to extract additional information from the HTTP request and inject them into parameters to our resource function. This example shows two different path parameters. Actually, they shouldn't say path, that's my mistake. They should be query parameters. So line 4 and 5, there is no such thing as a path param. This is me copying and pasting, apologies. Line 4 and 5 should say query-param, not path-param. And these are extracted from the query string of the URI. So in your URL or URI, there's often a question mark at the end, and then a number of key value pairs. This helps extract those key value pairs, or the values, I should say, of those key value pairs, into parameters for your XQuery function. So if there was a key value pair in the query string of the URI, which is name equals something, the something would be injected into the $name query parameter. And for min score, if there was a min score equals query parameter, the value of that would be injected into the $min score function parameter. However, there's also some type conversion here. So we've annotated it, we've specified the type on our function as XS double. So REST XQ will attempt to convert that string into an XS double. And the eager-eyed of you may have noticed on line 5 at the end, there's a 0.25. That is a default. So as query parameters are always optional, if it is not present, you can also specify an optional value. You can have as many of these as you want, as function parameters can be sequences. So if you wanted more than one, we could have 0.25, 0.7, 0.8. In this instance, we really only want one minimum score. So we've just put 0.25. And again, that is converted. The default value is also subject to the conversion rules. That gets converted into a double if there is no min score present in the query URI. The other types of parameters, form is for dealing with HTML forms and extracting the values from the fields that are submitted there. Headers are for extracting values from HTTP headers, unsurprisingly. And cookie is really a convenience for the HTTP header, which is a cookie, rather than you having to parse the value of the HTTP cookie header. This will extract the various parts of the cookie and inject them as a sequence as a resource parameter for you. Form is actually pretty poorly defined in REST XQ1, and that's something that we propose to improve in REST XQ2. Okay, serialization. I'm not going to dwell on this too much. We've covered that it's mostly XQuery serialization spec. The only additional thing is that a function may return an element as the first thing in its result sequence, which has extra metadata about how to produce the HTTP response. So we can set additional response headers, HTTP response headers, messages, response codes, and various other pieces. Okay, so proposals for REST XQ2. Our paper makes 11 distinct proposals. The hardest thing was actually trying to remember to stick to the scope of the vision for REST XQ and not just include everything that we could think of or everything that people may have asked for. One of the things that I think REST XQ does quite well is it's quite strict about what is in the spec and what is not in the spec. This doesn't mean that vendors can't add extensions if they want to, and there's various extension points in the spec. But I think it's important not to create a kitchen sink where everything is just included. Our paper also leaves a number of considerations that are still uncertain to us, open to future work. And we'll need to look at those in the near future, and I'll mention those at the end. Okay, how am I doing for time? Anybody shout that out? I think I've got about 10 minutes.
Okay, we have 10 to 15 minutes.
Okay, ooh, more than I thought, okay. Okay, so URI templates that are used in path annotations. In version 1, they could only capture a single path segment. So you couldn't cross a path segment divide. By that, I mean the slash within a URI path. A template had to fit between slashes of the URI path because it's a single segment. We've changed that now so that a URI template can capture as many segments as you want. We've kept the simple URI template matching that's in REST XQ1. We refer to this now as simple matching, and we've added 2 more modes of URI template matching, depending on the complexity. There's a basic regular expression matching, and there's a more complex capturing regular expression matching. I think this proposal will likely have the greatest impact in terms of adoption. It's the one that I think people have struggled with the most in the past, the limitations that we had in REST XQ1 in that area. I'd also just like to say thank you to Jim Fuller. I think he may have requested this as far back as, or not quite this, but something very similar, as far back as September 2012, which was just 3 months after we published the original paper and spec. So apologies it's taken so long, Jim. So this is rather simple enhancement in a lot of ways, but gives a lot of power. We're going to look at some examples of this so that we can see how it really works. Okay, so our first example here, our URI template on line 2 between the product and the summary segments has gained an equals sign with something after the equals sign. The thing after the equals sign, for those who aren't immediately aware, is a regular expression. This follows the syntax for regular expressions as used in XPath. It's not a Perl or a Java or a JavaScript regular expression. It is a XPath defined regular expression, or I think it's actually an XML schema, but it's the same syntax. What this will do is it will extract any number between 0 and 9 that appears 1 or more times, so basically a number. And we can see that given the path /product 4567 summary, the value of the PID resource function parameter is also going to be converted to an excess integer. So we're going to extract the string 4567, and we're going to convert it into an excess integer. So we now have the ability to do 2 things. One is be much more strict about what a URI looks like. Previously, we just matched the whole segment and said, yep, that's valid. This will actually reject, because it's a constraint, so this will reject HTTP requests that URI path does not match that regular expression. Okay, so our resource functions now are even narrower in the types of HTTP requests that they will match, or can be even narrower. It's up to you, really. And in the second example here, we have a normal basic template called common name. So that matches the entire segment, as we saw from REST So this is line 2 in the second example. But after that, we have this thing called subpath, and the regular expression there says any character one or more times. And so because URI templates can now match multiple segments of the URI path, we actually get everything that follows common name slash. So that could be something slash something slash something slash something slash something. It doesn't really matter. In the example given here, it is the text for the string from the URI sleep slash anywhere. We can alternatively write, and I'm still thinking about this because this might be a little bit difficult to implement. As I say, these are only proposals, but we could alternatively put the URI templates back to back without the slash delimiter between them. And in this case, a subpath would instead be slash sleep slash anywhere. Whether that is actually implementable, I'm not certain yet. We need to play about with that. Okay. So that's basic regular expression matching. That's all very nice, but perhaps we want even more control over the URI. And to do that, we can use capturing groups within regular expressions. And at this point, if you're not a regular expression aficionado, you might think this looks like total gobbledygook, and I wouldn't blame you. I'm actually very keen on regular expressions, but there is a learning curve. So a capturing group is where you simply surround a part of your regular expression with brackets, and it allows you to later access the bit in brackets as a distinct value or a group that contains that value. So on line 2, our regular expression after the equals sign contains 2 capturing groups. First is going to capture the characters A to Z that must appear 3 or more times. And the second capturing group is going to capture the numbers 0 to 9 that must appear 1 or more times. Okay, so given the URI path, product hat 9876 summary, we extract those values and they get extracted into an array, okay? And the reason for that is obviously we've got multiple values and we want to inject them into the parameter. And so for that, we use an array. The first value is hat and the second is 9876. We can't actually specify any conversion information here because the parameters of the function $PID must be of type array, okay? Now, we could perhaps say it's an array of excess string, but that wouldn't work potentially because what we're really extracting here is a string and a number. And maybe we want to know that it's a string and a number. So we just have to say it's an array. We'll come back to how we might improve on that in a moment. But before I do that, I'll just mention the second example here. There's a subtle difference, which is that instead of a single equals sign, there's a double equals sign. And the point with the double equals sign is that it also gives you access to what in regular expression terms is known as group 0. Group 0 is the entire match of the regular expression. So whereas group 1 is coat and group 2 is 1, 2, 3, 4, 5, 6, group 3 is the whole thing, which can be useful if your regular expression capturing groups are excluding parts of your regular expression, i.e. the hyphen that's in the middle. So sometimes you want separation of their information and sometimes you don't. And group 0, confusingly, gets appended to the end of the array. And we did this because there is no 0 index in XQuery for accessing sequences or arrays. And we wanted group 1 to be the first thing in the array, group 2 to be the second. So unfortunately, group 0 has to be the last thing, which we can grab, I guess, through finding the length of the array. Okay. So in the previous example, there was no type information. We can annotate our $PID within our function definition on line 3 with information because it has to be an array type. So what we have proposed is that we can also add optional array information, typing information into the URI template. So after the $PID on line 2, we have 2 type definitions. We have XS NC name, non-colonized name, and XS integer. What this is saying is it's saying that the first group that's extracted from the capturing groups defined in the regular expression must be convertible and converted into an XS NC name, and the second group must be convertible into an XS integer, and if it is convertible, then we convert it. So our array no longer contains 2 strings. It now contains a hat, which is of type XS NC name, and it contains a number 9876 of type XS integer. So we've regained the ability to explicitly convert our types. And we further restricted our URI constraint. These things have to convert, otherwise the URI is not matched against the HTTP request. Okay, the next favorite feature proposal for potentially REST XQ2 is support for JSON, everybody's favorite topic, of course. So REST XQ1, am I running out of time? No, I thought I heard someone shout. Apologies. Okay, I'll carry on. Okay, great, thank you. Okay. So REST XQ1 had no support for JSON. This is not to be unexpected. REST XQ1 came out shortly before XQuery 3 and targeted XQuery 3. XQuery 3 itself had no concept of maps, arrays, or JSON serialization. This was all added in XQuery 3.1. So we think that a new version of REST XQ should be updated to target version 3.1 of XQuery and its associated specs. Some people will probably ask me about XQuery 4, so I'm going to head that off by saying I don't think XQuery 4 is ready yet. REST XQ is quite a stable standard that tends to stay around for a while, hence 12 years. So I want to target something that is battle proven, and 3.1 has been out there for a while now. In terms of JSON in REST XQ, the serialization is really simple because we use W3C XQuery serialization spec. That already covers JSON, so we don't have to think too much about that. However, parsing JSON from the incoming HTTP request body is a little bit more involved. So what we can do is we can parse incoming HTTP request bodies that have the media type application/JSON or some sort of related subtype. And we do this only when a request body is requested for a method annotation. So a method annotation are the annotations like put, post, get, head. Typically, it's only put or post that have bodies. And so when we have a put or post annotation that explicitly declares that there is a body that will be extracted into a function parameter, if the incoming content type is application JSON and we consume that, we will parse that JSON into a map or array. We've decided to make this easy for ourselves by just saying that the parsing follows the rules of fn parse JSON, which is an XPath function that's defined that describes how to parse JSON into maps and arrays. So we don't have to write too much interestingly though, fn parse JSON takes a number of arguments about how to handle the parsing for JSON. Previously, we had no way of specifying arguments to a parsing function when parsing a request body. So we've added that. You can see that on line 2 of the put method annotation. So after $new product, which defines the name of the resource function parameter that we're putting the value into, we have some brackets. And in there, we have a number of arguments. These arguments are exactly the same as those taken by parse JSON, fn parse JSON, I should say, except fn parse JSON allows a fallback function. We don't allow a fallback function at the moment because it's not quite clear what the semantics of finding and looking for that and linking it to this would be. However, you get quite a lot of functionality even without that. Okay, the last bit, I'll have to be quick, is support for multi-part. We wanted to do this in REST XQuery, but we got bogged down in the implementation detail, which is to say we couldn't really figure out how to support multi-part requests and responses without modeling them as XML documents. And we felt that that could be very inefficient. These things tend to have large payloads, i.e. people have uploaded files or multiple files, and putting those inside an XML document and then processing them was perhaps not the best way to do it. And yes, I'm aware that there are the various tricks for implementers to avoid some of that, but it just felt a little bit unpleasant in the spec. This is compounded by the fact that a multi-part body can itself one part or any part of a multi-part body may itself be a multi-part body. So this thing is recursive. You can have multi-part inside multi-part inside multi-part all the way down, and this can get quite complicated. This is much more easily defined and probably implemented now that we have maps and arrays in XQuery 3.1. So we've revisited multi-part, and we have a proposal for that in our paper. We enhance the form param to handle multi-part form data. You can either access the simple value or all of the multi-part information, which is extracted into a map. I'm going to go a little bit quickly here because I'm running out of time. We can also enhance the method annotations, and this is probably only needed for the post method to handle any sort of multi-part. And again, this is extracted into a map. Thank you, Jörg. And the format of such a map looks like this. We have the content, destination parameters, the headers within the multi-part part, and the body of the multi-part, which can be string, binary, or itself multi-part, which we model as a map, so it's recursive. The response, you can read about that yourself. And then further proposals in the paper, lots of lovely things. Go and read the paper, it will tell you about this. And still to think about, the main one here is server center events and WebSockets. They require some sort of synchronous processing model. Debbie Lockett and myself talked about this at Prague in the past, still thinking about how that might best be done in REST XQuery. Questions? Thank you.
So thank you very much, Adam, and we still have time for questions. So.
Hi, Adam. Get well soon. I had a quick question about the regular expression example. You showed one example with two separate expressions separated by a hyphen, and I was just wondering how you parsed that and turned it into a single thing that produced an array for a single parameter.
Is this line 2 in the second example?
Yeah, that one.
Okay, so that is actually a single regular expression. It's everything after the equals sign and before the closing curly brace. And that single regular expression has two capturing groups. So I'm not sure about other languages, but I know in Java, for example, there's a matcher class. And that has a function for accessing groups by index. So you would simply call group 1 to get the value from the first capturing expression and group 2 to get the value from the second capturing expression. Does that answer your question?
No, I think this is my eyesight. I couldn't see the extra bracket around it. Thanks.
Thank you. And there is another question over there.
Yeah, same slide. What's the advantage of decomposing the parse fragment in this line 2 rather than doing it within the XQuery function?
So what's the advantage of decomposing it in the URI string? Okay, yeah, we could just not have capturing groups. And we would still have a regular expression that adds the same constraint to matching against the HTTP request. I guess the capturing groups are really a convenience, or I see them as a convenience. because I then don't have to write fn analyze string and process the output of that. Instead, I can have the logic for REST XQ inject these values that I'm interested in into the array for the resource parameter.
Okay, and the last question from Mike K.
Michael K here. This is all server-side XQuery. Any thoughts on turning this into a remote function call by doing the client side as well?
Turning this into a remote function call by client side. I'm going to be honest, Mike. No, I haven't thought anything about that. But that sounds really interesting. And if I was there, I'd come and talk to you about it in the next coffee break. Maybe drop me an email. That sounds really interesting.
Okay, so thank you very much. Adam, again.
Thank you, everybody. Also, here at the end, there is one.
And I believe that Adam is on this xml.com Slack, so if you have some more question about this very interesting proposal, I think you can reach Adam here and we can discuss this further on this channel, for example. Okay, bye-bye, and I hope you will watch us, not yet, watch us on YouTube stream.
I certainly will. Thank you, Jörg.
Bye-bye, thank you.
Okay, good afternoon everybody. Glad to be here. And in the next 30 minutes or so, I will tell you a story that started actually out of frustration. Frustration because it turned out to be so hard to create a good tutorial. A tutorial where everything and every reference and every stuff was kept consistent and what really allowed my students to keep their eyes on the ball about what was being taught. But it's also a story about how XML markup and XProc came to the rescue, and spoiler alert, it has a happy end. So, anyway, there have already been some talks about artificial intelligence here, and I tried also to create some illustrations for my talk. And what you see here is the result of the question, give me a cartoon of a teacher teaching XML. And as you can see, the AI really understood the concept because there's not a single angle bracket on the blackboard, and the guy's t-shirt is also a bit off. So maybe better next year. Okay. My name is Eric Siegel. I'm a content engineer, XML specialist from the Netherlands. I do all kinds of XML stuff. I'm also the author of a couple of XML books, related books, of which one with Adam Retter. But what I also do, I provide trainings for some of my customers on request. And stubborn as I am, I like to create these trainings and these tutorials myself because then I can really concentrate on what I think is being important. And that turned out to be hard. And maybe you wonder what's so hard about creating a tutorial. Yeah, it may be a lot of work, but what's so hard about it? So let me take you on the day of a life of a tutorial developer. So what I do is I create a presentation first with a lot of sheets. You don't have to read it, it's not important. But on these slides are things like, okay, please now do exercise this. And as we did in that exercise, well, there are references there. For the students, I prepare a set of files. Let's assume this is an XSLT course. So you have an instruction. I do it in PDF, could also be text. There's an input file because you're doing XSLT. There's a template file, which is usually just an empty root element, but could also contain boilerplate text or an XSLT program with a mistake that they're supposed to fix or whatever. And I also provide a solution and sometimes an explanation if the solution is complex. Also here you have things. For instance, the input XML is repeated in the instruction. because I say, here's your input, please change this element into that. And the same for when I have a solution XML, I sometimes repeat it in the explanation because that makes it easier for me to explain the thing. But then, also sometimes on the instructions are other references to other things in the tutorial. And I sometimes duplicate code from the set of files into my presentation because I want to have easy access to it while I'll present my course. And what I also like to do, and I'll tell you more about it later, I like to add some support, in this case an Oxygen project file, in which all the transformation scenarios are pre-cooked, so the student only has to press Ctrl-Shift-T and the transformation magically happens for them. That's nice. Okay, so far so good. But then I think, oh, this is not good enough, let's change something. So I change the solution XML, and then I have to remember that I duplicated this code in my presentation and in my explanation PDF. Okay, that's kind of easy, but then I insert an exercise. And then you can see that really the shit hits the fan, because you have to renumber everything, everywhere, every reference, in your project file, in your presentation, it's horrible. And after a while, and after doing that for several times, I start to feel a little bit like this guy here. It actually psychologically stops me from altering, from bettering my course, and that's a bad thing. So how can we amend this? Well, of course we have XML, right? I'm an XML guy, so can we take XML to the rescue? Okay, let's have a little bit closer look at the requirements. We have a teacher and we have students. For the teacher, I want to have a presentation. I like to use PowerPoint. There's nothing special about it, I'm just used to it. And I like to use the animation feature of PowerPoint, which you probably already have noticed. From there, for the students, I have exercises. Exercises an exercise consists of a set of files, as an Oxygen project for that, and everything gets zipped up into a zip file, so I can easily transfer this whole bunch to the students. There are lots of cross-references there and code applications, and the problem is, of course, how to keep these things consistent with each other, and also how can I more easily write an instruction or an explanation, because that's something you do quite often when you create these kinds of tutorials. One more thing here is an example of a sheet in a tutorial, and there are things here that I would like to keep consistent. For instance, there's a number of the exercise you need to do. There's the name of an input file, which can change based on certain parameters or certain choices made. And there's a piece of code there which comes from one of the files that the students already have, and that should also be kept consistent. Here's an example of an Oxygen file which is configured so it gives very easy access to all the exercises. Students can easily find things because they are in the project, and all the XSLT files are coupled to a transformation scenario, so you can just hit transform and it all works, which is pretty good. Okay, how can we turn back to XML? How can we put XML here to the rescue? Well, I started thinking about this, and the first thing, of course, is what you do. You think, I need a kind of markup language. I need some kind of course description markup language, or if you wish, a document-specific, a domain-specific language, a DSL, for this. This stuff references all kinds of input files you need for your tutorial. You still have to create them. And then you need some kind of huffing and puffing machine that turns this all into, for the students, a zip file, and for the teacher, it should create a presentation with all the references correct and all the code duplicated in the way it should be. And if you look at this, it might be a familiar pattern. It looks like a little bit like this. And instead of we run the results on our CPU, we run it on the wetware of the students and the teacher. Anyway, let's have a quick look at this course description markup I came up with. Here it is. Yeah. Okay, there's a prologue, which is boring. That's why I omitted it. Authors, titles, stuff like that. Settings, lots of settings. And then there is a section about a certain subject, and a section has exercises in it. And here's one of the interesting things. In this exercise, I describe what files belong to the exercise, where it can find them, and then it copies them to the result structure and gives them certain consistent names. They have an ID, which is important, because here I have an instruction. This is Markdown. I accept code in instructions written in Markdown or in DocBook 5, or even both, mixed can also happen. And there are references in here. For instance, here is a reference between @signs, which will be changed into the name of the actual file that the students see. Here is a reference that is changed into a code block with the contents of the file with that identifier. And there's nothing magic about the @signs or the triple block things. That's just a choice I made. It could have been anything else. And below here you see some instructions from which I can create an Oxygen project file, which says, okay, if this file is up, please use this transformation scenario to transform it, and the students can just sit back and be happy. How should so now we have to write an engine. We have our course description language, we have the idea of what it should look like. How does an engine look like? Well, if you like a hammer, everything looks like a nail. Yesterday we had the hammer which was called XSLT. It's also my hammer, but another hammer of mine is called XProc, XProc 3. And XProc 3 actually turned out to be very well suited for these kinds of problems. For those that don't know it, XProc 3 is a pipelining language. You throw in a document or multiple documents. You put it through all kinds of steps and outcomes a result, or multiple results if you want to. The good thing is about XProc is that it has all kinds of standard steps. You can do a transformation, you can validate, you can do X-include. It's all pretty easy to do. You can also do XSLFO processing. It handles XML beautifully. XML is its main language, but it can, at least the 3.0 version, can also handle other kinds of files, JSON, HTML, but also binary files, for which zip files are at this moment the most interesting. It can also do, very importantly, housekeeping. Things like creating directories, cleaning directories, deleting files, copying files, stuff like that. All these things where when you're doing XML processing only, usually had to go to AND or to an encompassing batch script or shell script or something. It's very easy to reuse steps, and I will show you how that works in a few slides. And it all runs on Achim Berntsen's very good Morgana processor. Let's take a quick look at how you reuse steps in XProc, because that's a feature that actually makes this whole thing very possible. If you have a step, this is an example of some step that merges something. I have no idea what it does, it's just an example. And you want to reuse this in a bigger pipeline. That's very easy to do, and it's a bit of an overlooked feature of XProc. So just a quick aside of how that looks in code. Here we have just a root element of an XProc step, do something, and we want to reuse this do something into a bigger context. What you need to do for this is you need to declare a namespace, any namespace, as long as it's not the XProc namespace. And then you give this step a type in that namespace. And then you write your encompassing step in which you use this one. And the first thing you do is import the do something. And then you can simply use this step, by using the type as an XML element name. So it's really very, very easy, if you've written a step before that does something useful, to reuse it in a bigger step. With that in mind, I started to look around on my disk what I already had written and or what I could find on the internet. And there were quite some things that were useful. I had Markdown to DocBook, already written, simple Markdown, but good enough. I had DocBook to PDF, which I use for producing my books. Working with zip files, especially Microsoft Office, we'll get back to that. And zip result directory, those kinds of things. So with this in mind, it started actually looking like this, like meshing up Lego bricks. I mean, you have everything and you just have to put it in another configuration together. And most of these Lego bricks I used, I think actually all of them are open source by me, and they were already on the internet, and here are the links, and these are also in the article. So with all these Lego bricks, let's put all these Lego bricks together and find out how this course description can be processed by XProc. So we start with our course description in the markup language I showed to you. The first thing I do is XInclude. XInclude is just a step in XProc, but it makes it so easy to design your input language with an include structure already there. I mean, you hardly have to do anything for it to make include files possible, which is a good thing, because sometimes it's easier to make your big file into smaller segments by including stuff. Then I validated also standard steps, hardly any code to write for it. I validated with a schema and with a schematron, but you could do either or both. Then I compute values. I enhance the XML structure with all kinds of values in a small sequence of XSLTs, add numbers, add paths, stuff like that. I'll get back to that. Which is actually a very important thing to do because it makes it easier for the rest of the XProc pipeline to handle the stuff. Then I process the text. I do the Markdown to DocBook conversions. I check for all these @ signs and triple block angle stuff to convert it and to put all the references. Then I write all the files, so I copy all the files for the exercises. I create some specials. One of them is and there are more, but one of them is the Oxygen project. I process the presentation. I'll get back to that, how that works, the PowerPoint, and zip the whole thing up, and we're done. So this is of course, simplified version of the XProc pipeline. Let's have a look at 3 of the green blocks here. One thing I found out is really important in doing these kinds of things is enhancing your XML with interesting data before you actually do the processing. And what I mean with this is, for instance, I compute the section numbers, I compute the exercise numbers, which are partly parameter driven, but it's also a matter of when you insert something, then the number changes, stuff like that. So you compute them up front, so when something references something else, you can quickly find the number for it. And you also often use this number in directory names and file names and stuff. Another important thing is that I change all the path references, all the URIs, into absolute URIs based on probably other parameters or where the source file is and stuff like that. As soon as you have absolute URIs, you can quickly call an XProc step, for instance, to copy a file, because you have both 2 absolute URIs. You can just copy this one to that one, done. You don't have to worry about where it is and what relative paths actually mean, but you have to compute that all up front. Another one of the green blocks is the Oxygen project generation. What I did, I just took Oxygen, created a few projects, and look inside. And hey, it's XML, that's great. And with a bit of trial and error, you can transform your source into an Oxygen project that actually works. There is, of course, a downside to this. It's a proprietary format. And as far as I know, and I've just talked to the Oxygen guys and they confirmed that it's not written down, there's not even a schema for it. but luckily they are not going to change it anyway. So that's good. Then the PowerPoint changes. Here is an example of a sheet, how a sheet could look like in the base presentation. You recognize the references with the @ signs and the triple angle brackets, the triple block brackets. And what I want to do is to change this into this. Well, how do you do that? Well, maybe you know, maybe you don't, but a PowerPoint file, actually any Office file, is actually a zip file with a lot of very, very, very complicated XML inside, which is not also complicated, but it's also interrelated. So they point to each other, and you usually need to access multiple files to get something done. Which is, because it's so complicated and some numbers are so obscure what they actually mean, it's almost impossible to generate. I toyed a little bit with, can I create a markup language for this? But the answer was very quickly no. It's too complicated. However, when you have an existing PowerPoint file, it's relatively easy to change it because it's XML, and hey, we can transform XML, right? So that's good. So I created a step which on the very outside looks like this. You put a zip file in, you put the course description in, and you process it so it dereferences all the references. Zip files are easy to handle inside XProc. And this link points to a YouTube film of an XML Prague presentation I gave a few years ago about how to handle zip files in XProc. Let's take one look down, one step down. We have the PowerPoint, and what I first do with the PowerPoint is a process I call containerization. I'm not sure whether there's an official term for it, maybe it doesn't exist. What I actually do is I gather all the XML inside this zip file, any zip file, into an encompassing XML structure. And I'll show you what that looks like. So now I have one file where all the XML in the zip is in, still recognizable, still round-trippable. But you have now one file. Because all these files are interrelated, you can then much more easily handle it by XSLT transformations, which if you put in one file are much more easy to write than when you put in multiple files. So what I get back is an adapted container file, and I decontainerize it, and I get a zip file back with adapted PowerPoint. Now this whole containerization stuff looks like this. It was designed with round tripping in mind, so this is a simplified version. There's slightly more information in it. For all XML files are just wrapped into an element in a different namespace. And this is repeated, the XTLCon document element is repeated for every XML file in the zip file. And for everything that is not XML, I just create a reference, and the decontainerization process is intelligent enough to know that it should take, when it finds an external document element, it should take its input from the original zip file and just copy it to the output zip file. Also, these containerization and decontainerization steps are in the open source, in the container, on the link over there. And I actually, a few years ago on a demo jam in Prague, I actually demoed this by doing this with Excel, taking an Excel file, changing it, and putting it back and opening it again in Excel. So this technique, this trick, works actually for any Office file you want. So, did it work? Did it actually happen? Well, I had the privilege to provide quite a lot of trainings the last few months for a number of clients. And so being aware that this was coming, I quickly put all my courses into this newfangled XML tutorial course markup, and I processed it. And I said, this is a very good test case. Let's see how it works. So what are the real world experiences? What are really the things I liked about it and the students? Well, the first thing is the markup was easy to create. It wasn't difficult. Yeah, I created it myself. I know I'm not really a very good test person, but I thought it was easy enough. Markdown for creating the text is in 99% of the time sufficient, so don't bother with any difficult markup languages. The training modules become very consistent and very, yeah, all file names are the same, all references are correct. So they're easy to interpret and use. If some students came to me and said, well, this is very good because we like that the files are all the same name. So they actually liked this whole idea. They actually enjoyed it. Once they got around and once they found out how the system worked, everything worked. Still, of course, small mistakes are easily made. You make a mistake in a solution or in an input file or whatever. It happens. But then, hey, I can just fix the mistake, press a button, and I have a consistent tutorial again. How nice is that? Let's wrap up. Yes, it helps. For me, it helps. But also the students think it's nice. And hey, single sourcing is probably always a good idea, isn't it? For me, XProc is almost the almost ideal mesh-up language. You know, you have components, stuff around that do some things, and you can just plug them together in different configurations. Of course, but that's with all things you want to reuse. Design your steps carefully, design them with reuse in mind. But if you do that, you have a really good tool at your hand. XProc is also very suited for processing markup languages, especially because it also can do things like housekeeping and stuff like that, which means you don't have to sidestep to Ant or other scripting languages. And as always, because what I showed you here was a bit of an idealized version, this was the first implementation. I thought it wasn't really good enough, so I'm working on version 2. I have lots of ideas, it's work in progress, so that's why why I didn't open source it yet, but I'm planning to somewhere in the coming month. So this is what I wanted to say about this tutorial development thing, how XML and XProc came to the rescue when I was creating my tutorials, and as I said before, it has a happy end. Thank you.
Thank you very much, Eric. So there is a question from Mike A.
It's a while, Eric, since I've done much training, but when I used to do it, my biggest problem was maintaining multiple versions of courses. The one-day XSLT course, the two-day XSLT course, with a lot of material common between them. Have you thought about how to apply this to versioning?
No, I haven't, but my trick is to create smaller modules. So I have an introductory course, I have an XPath introduction, I have an XT advanced, and depending on how long the course is, I just pick my modules.
Hi, Eric, nice work, but I'm asking myself, was it really necessary to invent another domain-specific language? The online training, SCORM, whatever world exists for a number of years, and was this really necessary? And what are the reasons you chose to do so, or why? What was the missing part in potentially existing solutions? I'm not an expert in that field, but that struck me.
Was it necessary to invent another description language? Yeah, for me it was. One reason is that I'm stubborn and I like to do it. I admit it. The other thing that there are indeed, there are always missing parts in existing languages, and then you have to add them, and sometimes they're not extensible. But I must honestly say I didn't really look at them.
Okay, so thank you very much again.
Okay.
Boris, and also related to XProc.
Okay, so now I will talk as an employee of Moravian Library, and I will present XProc library or set of XProc libraries for enriching data from digital libraries. Oh, sorry. I'm start timing and yes. So I think we'll agree that digital libraries are very useful for readers, for users, because they not also preserve cultural heritage, but because digital copy is easy to distribute, more users can read and get access to digital books. And in the last few years, they can be used also for machine learning. Digital libraries use a lot of standards. We had presentation this morning about this, so I can skip this. And this is an overview how metadata and data are stored in some database, and it's built around object, which can be a monography or papers, for example. There are metadata in Fox, XML, mods, etc. formats, and something I call data. For me, it's text from the book or from the page, and the text can be in plain text format or in Alto, which is XML format that describes parts of the page and text, also the text and positions of the text on the page. So here are some examples of digital libraries. I think you really know, so like Google Books, Internet Archives, or HathiTrust. And in Czech Republic, there are many digital libraries, because each institution, each library can have his own digital library. And these libraries, digital libraries, use software called Kramerius. I know also Polona from Poland, which is a little bit new product, or Bayerische Staatsbibliothek digital library. These libraries works as web pages for users, where they can browse the content page by page mostly. They see images of the text or text itself as a plain text or some layout around above the image. And sometimes data can be downloaded as a PDF or raw data in Alto format, for example. It's available on Internet Archives. PDFs are downloadable from Google Books. And for example, for digital libraries, check digital libraries. But sometimes there are some restrictions. For example, Google Books are not are only black-white resolution, and Czech libraries allow only not all pages to be downloaded. And now each digital library, as I know, has some API. For example, REST API and IIIF for images. This is how Czech digital library looks like. And one book that I will present here. This is some extraction of the REST API that digital library uses. This is for Kramerius, Czech digital library. The path to the resource, like auto document or mods metadata, are predictable because of the parts of the URL, and there is some identifier of the resource itself. Identifier is for monography as a whole or for individual page. So what is missing in digital libraries? Not in all, but in some of them. It's not easy to get all data and metadata for one book. Each digital library has its own access to data, its own REST API, for example. And as I know, only HathiTrust enhanced their texts with some linguistic metadata. So you can take only plain text from digital library. So my goal was to try do something similar for the user. That user can put identifier of some monography and push button and take data and metadata from the digital library on his or her computer. So there is a lot of types of data and metadata. Images are in JPEG mostly, but old Czech digital library use déjà vu format, for example, Fox XML, etc. Is in XML, but REST APIs use JSON. And sometimes not all data are available because it's missing, for example, a result of OCR, or file is somehow corrupted. And as I mentioned, there is a lot of softwares. Each digital library use its own software in the background, and for example, Czech digital library Kramerius develops, and there are at least 3 instances or 3 versions that are still running, and each version has its different metadata and different API. And the last point I tried to resolve was to enhance data by calling some external services. So this is how the solution looks like. There is one library I call Libri Augmenti, and this is some input point for the user. He or she can define identifier of the book, of the monography, where data should be downloaded, which data or metadata should be downloaded, how to enhance them, and that's all. And this library is responsible for creating virtual documents where all resources are identified with its URL. It also downloads data and enhance data by sending them to the external service. And there are separate libraries for each digital or for each version of digital library, and separate libraries for enhancements tool. We use UDpipe and nametag. These tools, are developed by Lindart Klariach and are available online. So this is overview of libraries and how they are connected, and this is how the process looks like. The library creates some virtual document that has for each resource its own element with URL. Then it is downloaded, etc. And this is the last slide of my presentation. I switch to demonstration X in Oxygen. So this is one step for downloading data from the oldest version of the Cramerius library, and the output will be here in this directory. So data are downloaded and the result of the download is not only the data itself, but also some report. Okay. For the user, with list of pages and links to the online version, or it's only text to the online version or local version. Yeah, this is online. This one is local, and because this is this library use déjà vu format, I also prepared some batch file that creates PDFs from each image and then combines all images, all PDFs to one. So it will be available for the users as a separate file. So this is one example, and second example is this book from 4 pages I showed you. Now I hope it will be downloaded. I'm in a different directory. As you can see, there are data and metadata, and now I will send this data to the UD pipe at Semantic services, and it will generate a TI document for whole book. So in a few minutes, seconds, there will be, new directory, oops. With this TI, as you can see, it's enhanced by lemmatization, name it entities recognition. Thank you for your attention, sorry.
Thank you very much. Is there any question? I don't see any questions, so probably everybody is looking forward to. Is there one? Ah, sorry. Yeah. Should buy new glasses. Wait for microphone.
Can you show us the XProc itself?
Yes.
I mean,
which one?
Slow enough that I can read it.
So the pipeline, it takes one document, its identifier, and then calls one step to build a virtual document. After that, it creates a report, then downloads data that are in the virtual document identified by URLs. And again, creates reports because then you can access data also local, not only online. Yeah, it's a different kind of document. So I have access to, for example, doubling core for each page. Is it?
Excellent.
You're welcome.
Okay, thank you. Is there any other question? I see none, so thank you. And there will be lunch. Today it will be on third floor as in on Thursday, so there are some special security changes today.
Maybe if
you can enjoy the lunch inside the restaurant or outside on the terrace. So enjoy and see you there at 2:30.
Yes, see you there. we organizers do. And we're going to give the microphone to, can you test it? Can you put it in? Yes. The microphone to talk about benchmarking of XML and XQuery database.
Can you say something?
Hello?
Yeah. Perfect.
Good afternoon, everyone. I'm Alan Paxton. I'm a senior engineer at Evolved Binary. I work on databases, concurrency, performance, and I develop in Java, C++, and XML and XQuery. I've been contributing to ExistDB for the last 3 years now, and this is some work I've done with Adam Retter, also of Evolved Binary, on benchmarking XQuery XML, and some work we've done to try and take that forward. So first of all, and actually for a lot of this talk, will be a review of XML benchmarking. So what does it look like now, a taxonomy, a history of benchmarking, and we'll place it in a context with benchmarking of SQL databases, benchmarking of NoSQL databases, and we'll get to a proposal for some extensions to a framework that we've started work on, though it's by no means complete, and we'll try and motivate why that framework does useful things for us.
Could you speak a bit louder?
Sorry, is that any better? So, XML benchmarking, taxonomy. As XML grew, so XML designed for document transformation with XSLT, and XML designed for structured data storage. So with document stores, and more particularly with XML databases, which take documents and decompose them into small parts and store them in a very kind of formalized and structured way at a low level. And the query, and at the same time, a query language evolved, which is XQuery, which standardized how you query XML databases, how you query XML documents. And so it became necessary to benchmark XML data stores, XML databases, XML processing in all the ways that it was done. And perhaps the first example of such a thing was the X007 benchmark. It's an XMLification, if you want, of a benchmark which was initially designed for object-oriented databases. If anyone can think themselves back to the days when object-oriented databases were a thing, they took the 007 benchmark and effectively translated it into XML data stores. Because at that point XQuery had not really been formalized, then the different databases had different query languages, so there was a lot of work involved in translating the queries of X007 between different databases, but ended up with at least some results on relative performance of different databases. So perhaps the most significant early, how shall I put it, the most significant early product of XML benchmarking was XMARC and the XML benchmark project. So 2002, so that's more than 20 years ago now. But it kind of covered the basis of how do you benchmark an XML system. So first of all, it's an application level benchmark. So what's that doing? That's characterizing the broad performance of a whole system rather than drilling into details. It's saying that this system performs well over a range of tasks, a range of queries, a range of workloads. exercise as many features as possible of the database system, the data storage system. I'm trying to be kind of language agnostic, because although I work on ExistDB, which is clearly an XML database, some of these projects are looking at more at what you would call document stores, which haven't really decomposed and processed the documents in any particular way. So obviously, these can perform differently. Now, the other interesting thing that XMark did was what we'll call scalable workload generation. So they built a tool called XMLGen, and they built it in C89. That's again, we're talking about a while ago. I don't think many people would build things in that now. But what XMLGen did was it generated an example database, the database formed one or many XML files, and the contents of the files were several different sets of structured elements, which simulated the elements that you require to model, in this case, an auction site. So there are elements that describe the items that were being sold. There are elements that describe the in-process auctions for particular items. There are elements that describe historic auctions that have taken place, and there are some more detailed item descriptions. I think I've mentioned that before, but the concept behind having these different sets of elements was they reflected different XML workloads. So some of them were text heavy but fairly simply structured. Others have deeper and more complex element structures, children of children of children, fan outs of various degrees. So once you've got that sort of database, the point is that it's going to, the hope is that that's going to exercise a large number of different aspects of the system in which you store that data. And then finally what XMark did was fixed a set of queries. By this point, XQuery is kind of much more standard, so you can express all the queries in XQuery, and then you can consistently compare implementations of XML stores with the set of queries on this database. And perhaps the one final point to mention about the scalable workload generation is these auction databases that are generated can be of variable size depending on how big you want them to be. So you can say, well, I've got this sort of system installed. A reasonable size of workload to test things is this big. Please generate me a database of this size, and it scales all the various components of the database generated so that kind of becomes a realistic model. Have I missed a step? There. So perhaps the next milestone on history is something called the Michigan benchmark. Difference compare between this and XMark, this is much more of a micro benchmark. So micro benchmarking, we're talking about drilling into the details of how a particular system behaves, perhaps for an individual query, a very tailored piece of workload, and it's often used by developers to analyze specific performance, figure out why a performance bug is happening, figure out how to improve the performance of a specific query. And then what Michigan benchmark did was they compared 3 databases that support XML, and again they were comparing across native and non-native. So a commercial XML database is one of these things where they won't tell you which it was because commercial licensing terms. A commercial object relational database. So again, this is storing XML through a relational object relational mapping, and the Timber database that was being developed at Michigan at that time. And what they were able to achieve with their benchmark was to identify performance issues in the development of the Timber database, and they claimed fix them basically because they could understand what was going on. So in 2011, there appeared XQbench. Rather than a new benchmark, what that contributed was more of an environment for how you do, for making it easier to run benchmarks. So it's and allowing more objective comparison of benchmark systems. So it would allow you to configure workloads and queries. It had backends running various database implementations, and it recorded results. So the idea is then you can just say, run me this workload against this database and report on the results, and add it to your store of information. And obviously it comes with extensibility. If you implement a new database, then you can help them, you can build a back end for them that runs XQbench workloads against your new database and demonstrates its superiority to all databases that have gone before. So this slight digression, I guess, because I am very much a database-focused person, but it's worth mentioning that some work was done on XSLT benchmarking by the Saxon people. So whilst obviously there's a lot in common between, I think people acknowledge that XSLT and XQuery can do a lot of the same things. The workloads that people in practice do with XSLT tend to vary from those that they do with XQuery. So XT Speedo has focused on XSLT, and I guess they're running workloads that were that are more tailored to the sort of things that people are doing with XSLT, and well, compiling a style sheet, running it 1,000 times against various inputs to transform it in outputs, and timing how long these things took. So taking a step backwards, what you notice about a lot of the things I've talked about is that they're not particularly recent. So it's perhaps arguable that not a lot has happened in XML benchmarking in the last half dozen years or even a wee bit longer. And in the meantime, in the rest of the world, SQL benchmarking has has continued to progress, and so perhaps the theme of what has gone on there is that people have introduced what they've called benchmark frameworks. So I use the term benchmark framework, or sometimes a test bed. In particular, something called OLTP Bench in 2013, and they use the term test bed for testing SQL databases, and they talk about driving relational DBNSs via standard interfaces, and being able to control the transactions you run against the databases, being able to control the request rates, being able to control how you distribute the requests across key ranges, across servers if you've got a distributed system, and automatically gather performance and resource statistics out as part of running the benchmark. And so what does an SQL test bed need? Well, OLTP Bench talk about synthetic and real data and workloads. So taking that back to an XML world, we're talking about XMark has these synthetic workloads, but lots of individual customers have corpuses of XML data that you describe as real workloads. You want to be able to use both in a test bed. You want to be able to, you have the convenience of generating synthetic test data, but you have the precision of someone saying, I want to know how your system behaves with my very specific workload. Then you should be able to handle both. Mixed and evolving workloads, so you can change. So things are not entirely static when you're running a benchmark. The rate of query requests, the balance of the different sets of queries, how they're distributed changes. So you want to be able to model that sort of thing, because you know how a system is going along quite happily, and you just get a few more queries to one key, and everything gets locked up, falls over. I'm not pointing fingers at specific databases here, but just in the general. This is the world of software systems. You can just make some subtle change to the workload, and you can provoke significant changes to how the system behaves. And you want to be able to simulate real-life events, well, obviously, and you want workloads to evolve. I think we've kind of talked over what that means. Fine-grained rate control, so talking about the fact that you can get to a threshold where the rate of transactions or the rate of requests changes very slightly and affects things significantly. So your test bed needs to be able to have these knobs that you can twiddle to make sure that you can just test it to the point of failure and no further, for instance, or you can test it to the point of suddenly everything takes 2 seconds to run a query rather than 200 nanoseconds. Again, talking about flexible workload generation, so rather than the data generation here, we're talking about the workload generation, which is the set of queries that you're firing at the databases in a running test. So you can generate that from multiple. You can configure multiple threads. You can configure how fast requests arrive. You can configure the balance of the different sets of requests that you're going to apply to the database, and which order they happen, one after another or randomly. And transactional throughput scalability. I'm sure that meant something when I wrote it. So moving on further, there is a system called NoSQL Bench, and in a lot of ways NoSQL Bench is very similar to OLTP Bench, but it's focused on NoSQL databases. In particular, it was initially developed for Cassandra, so it supports the CQL query language, but it also supports MongoDB, DynamoDB in a pluggable fashion, so you plug a backend that talks to a particular flavor of database into the back of that. And obviously, this gives one ideas about what other backends you can plug them into. It's got all the things we talked about from OLTP Bench, concurrent workload dispatch. Its workloads are scriptable. You write big YAML files that define all the different operations that define how you mix the different operations. I thought I'd said that. Shouldn't have happened. Your YAML file defines different sets of operations, defines how you distribute the operations, how many threads of operations you want to run, so you end up controlling all of these things, how the requests are fired at the database. And one other interesting thing that NoSQL Bench brought to the table is what they call virtual data sets. And they use these as operation field values. So each operation effectively fires submits an index to a generation function in the virtual data set to get the value for a field in the operation. So you can configure a key, for instance, to come from a field with a particular distribution so that you can focus a lot of queries on a particular point in the distribution of the keys, and have a tail of queries that go to fewer keys. It's very flexible from that point of view, and it's also repeatable. It's this classic pseudo-random number generator style thing. So when you're running query number 7,000, you're going to input 7,000 into the virtual data set generator, and you'll get the same values as you got on the last run. So you can consistently generate the same behavior on multiple runs of the database, of the benchmark. So obviously, what I've been leading up to, what we have decided to do and what we have embarked upon is some XQuery and XML benchmarking using NoSQL Bench. There are two things we needed for that, XML extensions to it. So first of all, we have built an XMLDB API adapter. So we have a prototype of NoSQL Bench running with this adapter, and submitting, you can submit queries to, well, we've used ExistDB, but any XMLDB should be fine. So we have been able to drive queries to that. So benchmark specification, a trivial benchmark specification with YAML, and queries submitted to ExistDB. The other thing we have done is to Bowdlerize, perhaps, but to take the virtual data set library that's part of NoSQL Bench and use that as an XML generator in the style of XML Gen from XMark. So, although that's not an adapter, but it is effectively, but it contributes to a tool that allows us to do much the same thing as XML Gen did, except it's in Java. It's in Java 21. We've built what we would consider an analog of the auction site, although we haven't. Our next step is to confirm that it performs in the same way as the auction site. It looks to an inspection level about the same, but we haven't entirely verified that yet. And our kind of fairly naively implemented XML Gen 2, as we call it for the sake of argument, runs at about 50% the speed of the original XML Gen. So by the time we've applied a bit of multi-threaded concurrency to it and a bit of optimization, we're pretty sure that we're going to be generating large data sets very fast, so that running benchmarks with that data and with generated data is going to be a reasonable thing to be doing. So this is just an example of workload configuration. Sort of what does the YAML file look like? Well, it's kind of uninteresting, or I've been looking at it too long. It's in you run a driver, you tell it which operations to run, you tell it how many cycles to run, you can template the number of cycles, you can tell it how to run the sequence. So it's sequenced over intervals. You could sequence it in different ways. How many threads should it use? An automatic number. It says 10 times the number of CPU cores, I think, is its default. And the way we've written the XMLDB API, it takes an endpoint parameter, which is, here's the XMLDB that you should be talking to. here's a little example of the configuration bindings. So what this does is just describes just names, fields, and how and what pseudo-random generators they come from. So if you're generating, for instance, a gender field, if you've got a person record, you can use the weighted string function, and you've got m with a probability of 10, f with a probability of 10, other with a probability of 1, or however you want to lay something out. Then you can cut that into the record that you generate, or you can cut that into the. Sorry, in this instance, it's not records you're generating. It's the benchmark operations, but we use the same functions when we're generating the generated test data as well. That's kind of the double usage of the virtual data sets. Slide on a little bit faster because I've got 5 minutes left. So that's just a little example of us executing a query to the XMLDB API by curly braces to substitute the virtual dataset values into the queries. And onto the XML generation tool, which, as I said before, is written in Java. So it's a slightly more verbose version of here's how we use the virtual dataset functions to generate fields. And then we've got a little bit of syntactic sugar, which allows us to write element name value kind of in the core of our code that generates this data. So again, slightly more detailed version of how we generate XML. This is generating an email address, and it's composing 10 different virtual dataset functions to come up with something that looks a bit like an email address. Enough. Again, the rule of thumb all the way through this is close enough that it simulates the workloads you're interested in, close enough that it provokes the behavior you're interested in. Be pragmatic about what you're doing here. Yeah, this is another instance of the same thing. It's just saying that this is an auction reference field. The auctions in the auctioned database are cross-referenced, and we're using a zip distribution so that there'll be more connections to a smaller set of auctions and fewer connections to a larger set. So the connection web between the different fields is non-uniform in that way. Yeah, a little example of our generator code. That's how we generate the mailbox element. So you can see here it's kind of a recursive. We've got an API. We've got this little bit of sugar API that goes element, the mail element, and here's a lambda that generates the sub-elements of this element. And as no one will be surprised to learn, we have an attribute method as well. So XML versus XML Gen 2, comparing them. For scale factor 100 dataset generation, the original XML gen written in C89, and which it's terribly easy to build and run, so I'm very impressed with that. It takes 221 seconds on my powerful little Mac laptop to generate what turns out to be 11,000 megabytes. And the implementation of XML Gen 2 is taking about twice as long, as I noted, and the file is slightly bigger just because of the way we've done the text generation. We haven't focused on making that completely identical. What are we doing next? Well, we're nearly at the point. It's frustrating to be nearly at the point and giving a talk about it, but where we can do the complete round trip, generate some data, stick it in the database, run some queries against it, get the numbers back from how that worked. And yeah, and as part of that, we'll start producing YAML scripts for the common benchmarks, We'll start with Xmark's most easiest queries and move on. And that's it. Any questions?
Thank you. We have a few minutes for a question. Yes?
Yeah, interesting. I've used some of those benchmark tools over the years. Just interested about your XML generation. Do you have features to customize the structures of XML documents that you generate? You know, such as how deep they are, or you know.
It's very much programmatic. So our first stage is that we're generating something that looks like the auction site from Xmark, but it's done in a way that, although it's Java, it looks it has a lot of syntactic sugar that makes it look like here are element, attribute, but it is Java, and it's entirely under programmatic control how you would want to do things like fan outs and depths or anything like that. So very much meant to be. You can generate whatever you want with this library, but it's a lot cleaner than just writing code from scratch. On the other hand, it's a bit more programmer centric than entirely specifying something in a configuration file, but it should be as flexible as you need it to be. We went through a stage of trying to do things entirely from the YAML, but that just didn't give us the flexibility we needed to simulate the auction site. So we've ended up with a more flexible system, but it's more of a bit of basic Java knowledge to be able to use it.
Okay. Still time for one question? Okay. Thank you very much.
And there's a paper in the proceedings, so please go and read that.
Wait a minute, it's okay.
You need slides? No, we don't need slides.
Yeah.
Okay.
Next speaker will talk about semantic data modeling.
Hi, now we are switching gears from benchmarking bits and bytes in databases to more how to model certain things in complex standardization scenarios. So without further ado, let's up front. So it's a project, permissive license. There are the links to homepage, not very much up to date because we were very much concerned to get the thing going and not so much in documentation, but it will improve over time, so it's work in progress. And there's also the repository to all the source code. However, we are not going into technical details today, so we will spend some time on the motivation because it's very important to understand why we came up with simple semantic modeling in XML, where we try to emphasize the simple aspect of it. And then we will, of course, show some XML, but just on slides, no demo, and, of course, conclusion and what's next. So, who we are, that's the other thing. No? I think it will be the only presentation here at XML Prague this year with two people. So I'm Renzo Kottmann,
And I'm here from the, in English you call it the Coordination Office for IT Standards. So we are an organization within the public government, or public sector, I think it's the correct English. And I hope that's the only time where I do it. And you can see us here. So organizationally, we are part of the administration, an organization within that, tasked to do standards and introduce standards in the whole, for a whole German administration. That's, so to say, our organizational scope. So, and that's why we are a bit concerned with how do we develop and maintain these standards, and also on research to not only just do it, but get some more insights. And that's why Cedric is here.
Yeah, hi everyone. I'm Cedric Pauken. I'm from the University of Poland. I'm still a student actually. And I also work in the research group of e-government. And so a big focus for us is how we can actually efficiently develop IT standards for the public sector. And that's exactly the reason why we met. And I think you can really say that we've really found each other. And that's also why we are presenting some CMOCs together today.
Okay, so I will continue now. So the general problem statement, it took us quite some time to try to nail it down for this audience here, is I think especially most of you have read a lot of standards, mostly technical. We are about data exchange standards mostly, and have even been involved in developing super great standards. So our perspective for today on this is, you could see like, how do you publish or how do you put standards into the public? Now you could say in one extreme, you just write some Word document and just put it there and just publish it somehow in the internet, or HTML or PDF. So you write down for humans things about the standard. So that's what we call here now the document approach. Or the more it's about data and data exchange and data modeling, you do a data model approach. So in history, there's a lot of use of UML for modeling classes of data and all that stuff. RDF is, of course, pretty famous with its graph approach. Or even in the COSIT, so where I work, we developed already, like, I don't know, 15 to 20 years ago, the so-called XEV. It's a German acronym. I don't try to translate it. Okay, I can translate it. XML for the public sector. So that's the name, actually, which is a methodology which in some contexts do not work for us, and we are not we choose then a different hammer, yeah, if we are faced with different nails. So you could call this stuff the model approach, and of course in reality there's a mix of that. Especially it's in XML, you do some documentation of, and you publish, for example, the XSD, you could say. That's a mix of these two. And mostly, of course, there are these standardization organizations which we mention because we are not just developing standards from scratch, where it's absolutely not necessary, especially in the sector I'm working for, and also Cedric already did some research in public procurement. We are we are relying on standards from the ISO, from PEPOL, the CEN, and so on. And they all have their own ways of doing any combination of document approach and model approach. And because that's part of this problem statement, my thing is we are really working with domain experts which have super no clue about XML, and we don't want them to teach that to them. I mean, if they ask for, of course we do it, but it's like we don't want, how to say it in English, that they need to learn it in order to work with us. Let's phrase it like this. So therefore, we are very much in everyday work concerned with the imbalance between the technical side of implementing standards and business perspective, all about the requirements and all the knowledge that these experts in their domains have and how to bring them together and so on. And of course, we do a bit of kind of simple publication, producing PDFs and so on. And all these organizations, they have their own, mostly totally proprietary mix of technologies, which is fine. That's just the environment we are working in. So, and to get a bit more concrete, I already presented, next slide please. I already presented a testing tool in 2020 here at XML Prague, and I think I also used this use case for the motivation. So, as I said, we are not inventing standards, and these standards that we do, in this case, are required now by law. So, the European Union said and tasked the CEN, we want to have invoices to be required for all the public sector, that they are capable of receiving standardized invoices. So they made it a law, they tasked the CEN to do a norm on this, and they published this as a PDF, so it's a CEN standard, and when you read this PDF, you realize that they developed, in my opinion, super great semantic model about invoices. And which rules apply on them, and the specificity here is that they did what I call an Uber model, because CEN was tasked like, hey, there are already formats and out there, don't reinvent the wheel, harmonize their semantics. So it's, therefore they have also syntax bindings defined to, I think many of you know the Universal Business Language, more known only in Germany, France, as a cross-industry invoice. So that's why they described it very semantically. And they, in my opinion, they did a really great job about that. And what they also did, I think it's also known to many of you, is, and was mentioned in some talks today already, like, yeah, they defined like, how can you profile our standard for national needs? Yeah, because there are different regulations in every member state. So we do, so to say, very abstract invoice, and you can make it more concrete. So they call it a usage specification. So our task was like to do that for the member state called Germany. So we had to ask ourselves questions like, yeah, okay, that's now a PDF document that describes a full model. Do we also describe the full model and add just silently our specific rules and specific stuff to it? Or do we just describe the difference to what the CEN norm says? And how we do it? How do we do it? So the hammer called XFV does not work for that, because XFV is always done for the standard one format, and here we had to support 2 XML formats. So document or data model, or which combination of that? So bear with me, last motivation slide. That's actually the metaphor which I came up some time ago, so it's a lighthouse. So what we are trying with the standard is, of course, to put a lighthouse out there, so, and take a 360-degree perspective. We try, yeah, our best in that, and give then best guidance to people who have to implement these standards. So, and we do it on 2 levels, 2 layers, really from bottom up. The whole semantic definitions of like what requirements are there, for example, now on invoices and so on. I'm not explaining the left side because Cedric will go into details. What I want to say here is that Ms. Semox plays at the very fundamental part, and we go then in the development phase bottom up. We really try to bridge the world of domain experts and software developers. So when we do standard, we not only publish then a document, we also, it was this morning the topic, we are very keen on publishing validation artifacts, so validate soon and validate often. So we really support that and push the people to do it, of course. That's why I'm also concerned with like how to translate all these business aspects in artifacts like test messages is very important for us, schematron, code list, and so on. So with this said, that's the problem. That's where we, in this setting, came up with Zemox. I give the word to Cedric now.
Yeah, and so I will now be explaining the basic building blocks of Zemox semantically to you. And so we really try to eat our own dog food here. So we will be explaining Zemox by using XML examples of Zemox's own Zemox model. So the first basic building block is the term, really. And terms capture concepts, right? So a term is a word or phrase that captures a certain kind of concept in a certain kind of knowledge or business domain. And so whatever concept the term expresses, really, we domain experts have to name and describe it, and we then have to capture that in the model. And so what you can see here is a simple example of the term itself. So you can see that it has the term ID term and also a fitting name and description. Second, data types. So data types in general are pretty fundamental, of course, to programming and software languages, software and programming languages. And so semantic data types really are, of course, just high-level declarations of computer representations of data. And so it's pretty similar to the term that whatever the semantic intent of a data type is, it has to be named and described. And here, very simple example of the data type string, which of course I don't think I need to explain. And so data types give us very valuable information actually for the technical implementation. And so therefore, and I will also get to that shortly, each definition of a term should also include the declaration of a data type. But first up, there are some further semantic data types in Zemox. These are not all, but some we want to talk about. So first up, for example, we have the data type any, which is basically like the UR type, you could say. And so any is a very useful data type during actually, well, the modeling of things, because it can be used as a placeholder where you are not really certain yet what kind of data type a term will have. And so you can just use the data type any, for example. And then we also have the data type group, which really just indicates that a term groups other terms together, right? And so lastly, of course, easy example, IDs, identifiers. And so what we can now look at is a list of terms with data types. And so inside our Zemox model, we have our definitions, and inside the definitions are our terms. And we can then define the term definitions, therefore, as a data type group with the description that it's a list of all the terms in our model. And so, of course, we also, for example, have name and description as terms. And they both, of course, have the data type of string. And so next up, then, really is the question of, well, which terms belong to which, well, group of terms, right? Because we want to be able to build a structure, really, with the terms. And so a structure defines the affiliation between terms and groups, and also their cardinalities. And it does that in messages. And instead of messages, you could also say payloads, documents, data formats, you name it. And so one structure, for example, may specify a certain term as optional, another as mandatory, and then one even more as forbidden, for example. And so here we have a partial semantic structure of the Zemox itself model that we've already been taking some examples of, right? So you can see that the structure idea here is Zemox, it's our logic structure, and then we start building the message. And so we start with our root group of model, which may contain some metadata and also a short name, right? And then the definitions that we've just talked about. And then also, which we will get to very shortly, rules that we define, right? It's also a very essential part of Semox, but I will cover those shortly. So, in order to exchange data, we need to parse data. And so structures are bound to XML instances. And so what we can see here is very simple, that the Semox structure that we've also just looked at is bound to XML instances with the name Semox model, right? And then, so here we can then specify, right, our bindings. And then, for example, here, very simple, we can define that the data value of the term model is at the XPath/model, right? And we can then do that for all the contents. And then we have our syntax binding. And then, so the last basic building block, rules. So rules impose restrictions, assertions, constraints on terms and structures, really. And so, at least from a Semox point of view, rules should be developed from a business perspective. They should specify which terms they actually apply to, and then also, ideally, be testable via a simple yes or no answer. And then, lastly, what's also important is they should also provide references for implementations, as they basically set the expectation levels against which the technical implementation has to be measured against. And rules are defined in Semox, but they are implemented and validated basically exclusively via schematron. And so a rule might also belong to one or more rule groups, which as of now really is mostly just for logical grouping of rules. And so, for example, we may have certain data type rules, and one of those rules that we can then assign to the data type rules via a reference, via groups here, is, for example, the rule that each message in a structure must begin with a root group. And so then we also specify that this should, of course, this rule should apply on the term data type.
Yeah, and that's already about it. So when it comes to what are the main aspects of the Semox approach in XML, so here what I forgot to mention is, it will come later, these building blocks that are described here is also really the way how we talk with the experts. So we ask them, so what's important in an invoice, what's important there? Then we get to know phrases, terms, and so on, and just on this semantic business level. And also we do this with rules. So this is from another standard called eForms. It's even more complex scenario than what I described with the e-invoice. It's also more described in the paper here in the conference proceedings. Here it's just like, okay, excuse me for the German text. This is the agreed rules with a group of experts, around 30 people from all levels of public administration, knowing all the details of public procurement stuff, and we came up with that. So that's then put into XML, structured exactly that way and no way different. So, and of course, which I already mentioned, next step, so to say. Thanks to kudos to Jirka a lot. He helped a lot. And then coming up, like, of course, these experts we don't want to let them read the XML. So their way of doing things is PDF. So we have also a nice generation pipeline to then create PDFs. So the eForms PDF is 1,300 pages with a lot of stuff. This is a very little excerpt. That's how we render this rule sections from the XML. And I hope, Jirka, we will sometime talk about how there are some little nice tricks in how we really separate the structure, the content, from any aspect of technicalities, from any aspect of publication, and still have a very configurable way of producing PDFs for different scenarios. So the X-Rechnung PDF looks different than here it's eForms. So that said, already, I think we are quite good in time, I hope. Let's come already to the conclusions. So what I showed here is like, so we developed these standards. They are out there. They are already by law required that, for example, in e-forms, all public procurement agency of the German public sector have to send e-forms to German central database and to the European database. So, and the generated PDF is really published in the archives of the Bundesanzeiger, so that it's all legally, legally based standard. So, but the CMOX model itself is that simple, and it proved to just really work. So we left out a lot of details of that we are tailoring and doing profiles and all that stuff. And so we just have a simple XML standard, XML instance. So, and for us it was very important that these instances are, of course, shareable. It's technically a no-brainer. Organizationally, that's for us a big step forward because, for example, in this XFV context, these are not shared artifacts. And yeah, of course, we do validation during the development of these standards on the level of are we consistent? He showed the example of we defined the any data type, thanks to, it's shamelessly copied from XML schema, of course. We do checks like before we publish, it's not allowed that the data type any is in use. We do a lot of consistency checks, name it. I could do a talk on interesting schematron rules just for all these consistency checks. And now, because of this morning talk, I would say, yeah, and this is archivable in a very easy way. Yeah? It's XML. And that's hard to prove. Anecdotally, we have now 2 standards where I personally would say, without CMOX, we wouldn't have been able to do e-forms in time. That's another story. So for us, it's just a claim to say, for us, it really proved that we are more effective in standardization. But, okay, sorry, I forgot that. That's where we want to also put more research in, like, is it really that effective? Anecdotally, it is. And for us, it really proved, you can also, how you say, put a 90-degree turn of the picture and say, so, there's a semantic layer and there's a technical layer, and we really separated it out. So the semantic layer has absolutely no clue about the technical layer. And the technical layer is also very important, as I mentioned at the beginning. And there we will also do much more work. And having the semantic layer structured in a simple XML, we do, it's one thing that I say, we do a very simple thing. No? So the schematron implementation of the rules that we showed is totally done separate. It's an own project, no? The schematron rules for standard X. But to prove just simply are all rules implemented and so on, we use schematron to check the schematron for are all rules mentioned in the CMOX model also in the schematron just by ID. So we just give them the same IDs, and we can do a lot more just because now we have this, all the semantics captured in this XML on the level of ensuring that the technical implementation of the validation artifacts are also on the semantic level consistent with what the domain expert said.
Okay, and so I'm going to keep this short since we're running out of time. But this is really the basic illustration that it breaks down to, right? So in a group of experts, when you have all these expert discussions, it only needs one person to actually encode the results of the discussions in a CMOX model, and then produces a specification, and then all these domain experts can validate the input based on the specification. So the big advantage here is that they don't have to know any XML, and a lot of them really don't want to know any XML or even look at anything technical. So this is a very good bridge. And then on the other side, because we have this data model first approach, we basically give full freedom to the technical implementation. And so it can really bridge the gap between people with technical, legal, and business expertise, which is very, very important when digitalizing the public sector. And, of course, it's technology neutral, which has a bunch of different benefits. It offers a common foundation for standard definition. And, yeah, so what's next, to keep it short? Transactions. There's a lot of transaction usage in like the Uber standards in Sen and Peppol, which we want to integrate into Semox as well, which usually include the concept of information requests and responses. So this is work in progress. And then also there are more generic scientific research needs. So very, very much needed is a comprehensive classification in scientific literature. Then also, as Renzo already talked about, more empirical verification, of course, because this is still quite young, of course. And then it would also be very cool to have frameworks that specify best practice applications of Semox. So thank you very much for your attention, and we have time for questions now.
Thank you.
Thank you. We have time for questions. Oh, sorry.
Thank you for the talk. Did you consider at all using existing standards like SCOS or even OWL to do the modeling?
Yes. We had this also as a reviewer comment, and that's what I like about it. So I had to think about it more. So the main difference here is, so in the paper we add a paragraph, and this is the scope is totally different. For example, to scores or topic maps. So and that's why we emphasize so much, like we are standardizing data here. So we take the perspective of there are 8 bits. What meaning should they have? In this world of how I understand it, of scores and so on, it's more like there are humans agreeing on, we know that there's a concept in our real world, how do we encode it? So it's a bit like, it doesn't fit very neatly. And yeah, I keep it there. I have a second argument, which I forgot because I'm nervous.
A somewhat related question. I was disappointed to see that you hadn't related your methodology much more carefully to the sort of 50 years work that's been going on in database modeling and semantic modeling and conceptual schemas and before that in back to Aristotle in how you classify the world and decide what types are, and it all seemed a little bit loose in terms of defining terms. One of your slides said you'd only need one person to define the term. My experience, I mean, I had a workshop where I had a team that spent with a team from a television company, and they spent 3 days debating what a channel was. And they all disagreed on the concept. And I've seen systems fail because they hadn't agreed. For example, we had a major problem in the logistics of the UK National Lottery because people hadn't agreed what a terminal was. Those definitions of terms to me are absolutely fundamental, and the relationships between terms, the subtype relationships, the aggregation relationships. This all seems a little bit wishy-washy in that sort of area, if you don't mind me saying so.
To be honest, okay, you see it as a criticism, and I see it as, I think that's part of why that works in practice. And to be honest, I would like to write rigor research-driven comparison to all these 50 even, I mean, it's as old, I mean, it started with Turing, or how do we model data and so on. So here the focus is very practical, get this thing going. And on the web page I once wrote, it's an amalgamation of a lot of these stuff. So I used to work for standardization in biological data area. yesterday there was even an example of that, what I co-developed. So there's a lot of this experience. And one of these experiences, like, let the people fight 3 days about the concept, and just about that. Once they agreed, it's that simple to write it down. And subclass relationships and things like that, they are also very important in the discussions. But when you at the end have to define a data format, the subclass relationship of the real-world knowledge concept might be totally different than when you consider archiving needs of how the XML you want to do. That's why we make a structure and just call it group. We don't overload it with more semantics. So it might be a subclassing kind of relationship. It just might be like a relationship like, if you want to give information on that term, it also needs the information on these and these terms to make it complete. So in a very pragmatic sense. And yeah, I hope I answered you. You said a lot of stuff, so I hope I could pinpoint to some aspects of your...
You're being very pragmatic, and that has advantages.
Yeah, for example, and that's also, so I'm really here for the discussion. So based on, so what we didn't emphasize, so this list of terms is in Zemox really flat. It's just like no relationships, so it's the separation out that we say we can define structure where we do a combination, and we can define many structures and say this is, for example, the more ontological structure of the things. This is a structure to be syntax binded to some XML format. This is the structure for visualization. It's also about separating this out. And that's what was my argument that I forgot before. And SCOS has a very nice way, very few terms on in order to define relationships. Technically, we can add exactly the SCOS definitions or the SCOS way to these terms, although the list is flat, but by reference exactly construct, for example, a more ontological or taxonomic subclass relationship to the terms. As simple as that.
I think it's a good subject for during the last break of the day. Maybe just one last question, and quick maybe. So.
I might have missed it in the beginning. I wanted to know if semantics was a driving force and you want to accomplish a shared understanding between those governmental entities, whether you ever consider to simply use RDF instead of XML, or was it out of not a possible switch?
It was also considered, and in this case, again, a very pragmatic approach. So COSIT has now 35 people working on different kinds of standards. Almost all of them know XML. Almost nobody knows RDF. Very simple, to be honest. So.
Okay, thank you. Thank you very much.
Maybe you can try to attach it again. It's not sending signal.
Thank you. Right, good afternoon, everybody. My name is Rob Walpole, and a bit about myself. I've been working with XML technologies since about 2005, and I've been working with semantic web technologies since about 2008. And today I'm going to be talking a bit about knowledge graphs, a bit about personal knowledge graphs, my interest in personal knowledge graphs, which is to do with journaling. I'll explain that a bit more. I'll talk about how you might be able to create a personal knowledge graph, and a little bit about genealogical data, which can go into that knowledge graph. I'll explain how. And I'm going to talk about RML, which is the RDF mapping language, and YARML, which is a YAML version of RML, which makes life a bit easier. And then I'll talk a little bit about what this might lead to in the future, what possibilities it opens up. So knowledge graphs, I imagine pretty much everyone here knows roughly what a knowledge graph is. Perhaps the most commonly known one is the Google knowledge graph. So if you search for a term about which there are a lot of documents on the web, you'll probably see a box like this one, where Google have amalgamated some data from different sources, usually Wikipedia, probably a website from the place itself. Another knowledge graph, very well known one, of course, is DBpedia, which is the knowledge base behind Wikipedia. Another one which is quite well known, Wikidata. Quite a nice one because that's one that it's very easy to edit yourself. If you haven't done so, I recommend having a go at that. But what do we mean by a personal knowledge graph? Okay, that's a good question. It's quite a new concept. I recommend this book. I think it's the first book that's been written about personal knowledge graphs. It's a collection of essays, really, but there's some really good information in there. And in the book, they identify 3 types of knowledge graph. So there's the open knowledge graph, or the OKG, which is the kind of thing we've been talking about, Google, Wikipedia, DBpedia, Wikidata. Then there is the enterprise knowledge graph. So these are quite often closed knowledge graphs, or linked closed data, you might say, which are used by businesses such as IKEA, Airbnb, BMW. There are lots of other examples. In fact, there's now an enterprise knowledge graph foundation. And then the third type of knowledge graph they identify as the personal knowledge graph. But what is that exactly? So one definition from Ruben Verberer is it's all data that you yourself create combined with all data that others create about you. It's quite a general definition. Here's a slightly more specific one. A personal knowledge graph is a knowledge graph where a single individual called the owner of the PKG has full read and write access to the knowledge graph and the exclusive right to grant others read and write access to any specified part of the knowledge graph. The primary purpose of the PKG is to support the delivery of services that are customized particularly to its owner. Okay, so there isn't exactly an agreement what a personal knowledge graph is at the moment. It's definitely a work in progress. When I'm talking about personal knowledge graphs, what do I mean? Well, I see it as a knowledge graph with me at the center of the knowledge graph, and everything links out for me. So it links to people, places, and things that are important to me. My knowledge graph is linked closed data, so it's linked data, it's written in the linked data using all the standards of linked data, except that it's closed, it's not open linked data, so it's private. But I believe it also has the possibility of sharing, selective sharing of information within a personal knowledge graph with other people, and I'll talk a bit more about how that might happen as well. So my personal interest in, well, personal knowledge graphs and knowledge graphs in general is to do with journaling. So my family seems to have a history of writing journals. I keep a journal on and off, have been doing for many years. I think I got it from my mum. She was also a keen journaler, and my father as well. So I've spent quite a lot of time looking at journals, trying to find things in journals, and this is a little snippet from one of my mum's journals, just to give you an idea of the kind of thing that you might find in journals. I mean, journals are very personal things, but there is a tendency to find certain things I've noticed over and over again. So this is what I would describe as a 2D traditional journal entry. It's a piece of text, and if you're lucky, it might have been written on a computer. More likely, it's been written on a bit of paper and it's disappeared somewhere. So what are the benefits of linking a journal to a knowledge graph? One of the key things it gives you is the ability to disambiguate terms. So when I've been through my dad's journal, he's talked about things. He served in the Navy at one time, and he was on a ship called the Birmingham, and he talks about Birmingham, and he says, Birmingham this, Birmingham that. And if I didn't know my dad, I wouldn't know that he was talking about a ship. How do I know he's not talking about the city, Birmingham? So this allows you potentially to disambiguate that kind of thing. It also potentially gives you a better way to search for things. If you're searching for an entity in the text, then that's going to be easier to find. The act of linking a journal to a knowledge graph quite often brings more meaning. So if you create you're writing something, you go somewhere, Paris, whatever, and then you link it to DBpedia or something like that, you'll probably read a little bit, and maybe you'll learn something you didn't know, so you get some new meaning. It also makes it easier at a later date. So journals, people tend to keep them for years, chuck them in a cupboard, forget about them, and then they go back to them and, what was I talking about? I don't even know what I was talking about. But, if that journal had been linked to entities, resources in a knowledge graph, it might be a bit more meaningful. And also in future, if you keep a journal and put entities in, link it to a knowledge graph, then potentially you might be able to access an AI-based personal assistant. We all know now that AIs work better if they have access to structured data, such as XML or to RDF data. It tends to give less hallucinations and more accurate results. So if we go back to my mum's journal entry, and we'll just talk about what we find, what kind of things I said we might find in there. So you tend to find things that are public and notable, that kind of meet the Wikipedia notability criteria. So something there's lots of documents about, lots of people talk about. So that could be a city that you're visiting, or a movie that you've watched. And then you'll find things that they're not personal things, but they're kind of a bit more localized. So, you might talk about a community group you're involved with, or a restaurant that you go to locally, something like that. But you're not going to find that in Wikipedia. And then there are things that are really only kind of notable to me. So people and places like my grandfather or my grandfather's house. I mean, that's meaningful to me. It doesn't really mean anything to anybody else. So, so looking at those three categories. So the first category, as I said, probably DBpedia, you'll find something in there. A local, let's say a local restaurant, you're probably not going to find that in DBpedia, but there's nothing to stop you creating an entry in Wikidata for that. And I've done that myself a few times. But my grandfather, well, he's not going to be anywhere other than where I put him. So personal knowledge graph is potentially somewhere I might want to do that. So if we go back to this journal entry again, and just have a look and see. So we've got some things that I would say we're going to find in DBpedia or Wikipedia. So we've got London, Barnet, which is a suburb of London. We'll find lots of information about that. Taj Mahal. Okay, well, I know that that's not the Taj Mahal. That's a restaurant. So I'm not going to look for that on DBpedia, but maybe I could create an entry in Wikidata if there isn't one already. But then there's all these people. So this, got to remember, this is my mum talking. So she's talking about her mother and her dad. That's my sister. That's my dad. That's my dad's aunt and my dad's uncle. So there are all these people that are being talked about, but they ain't anywhere on the web. You're not going to find those in any existing knowledge graph. Okay, so let's say I decide to create a personal knowledge graph and put these people into it so that I can reference them from my journal. So how might I do that? Well, I could take a very naive approach and just start creating some RDF. So here we go. I'll create a resource for myself, and I'll say I'm a FOF person, and I've got a given name and last name. Great, so far so good. Okay, so yeah, I'm going to add my parents. So I'm going to create a resource for my mum and my dad, and my sister and my brother. And then I'm going to, of course, my sister's married, so I need to create an entry for my brother-in-law. And maybe they've got kids, so yeah, I need an entry for my niece and nephew. And suddenly I've got my work cut out. I've got to create all these RDF there, and I haven't really got time. This is something I do in my spare time. I haven't got time to do this, so forget about it. So maybe there's an easier way to do it, though. So that's why I started looking at genealogical data. So genealogical data, there's a data format for that, which is called GEDCOM, stands for Genealogical Data Communication. It's a de facto standard for genealogical data maintained by Family Search, which is a non-profit organization. Okay, so here we've got the Waltons, which I'll use as an example. Obviously, I don't want to talk about my own family, so we're going to use the Waltons. If you came to the demo jam last night, you'll have seen them before. So I went into, I used Ancestry. There are lots of different places where you can create family trees quite easily with a nice GUI. So you're not worrying about creating RDF or XML. You can do it all using a nice GUI. And then most of them will allow you to download that in a GEDCOM format. GEDCOM 5.51 is the kind of industry standard for genealogical data. There's also a GEDCOM X, which is it's not a newer standard than GEDCOM 5. It's a different format. So it allows, so it gives you the option of getting the same data in JSON. And more interestingly for us, it also allows you to get the data in XML format. So you can also export relationships. So this is a relationship of the type couple. So it's a symmetrical relationship, so you have two people who are in a relationship. You have parent-child, so in this case, the parent is the first person and the child is the second one. So how do we turn this into linked data? Okay, so this is where RML and YARML come in. So the RDF mapping language, RML, is an unofficial draft specification, but it's an extension of R2 RML, which is a W3C recommendation since about 2012. And R2 RML is for, if you're not familiar with it, for extracting RDF from relational databases. But RML is a generic mapping language, so it adds on top of the ability to extract from relational databases, ability to extract RDF from CSV, ability to extract from JSON files using JSON path, which a few other people have talked about in this conference. And from our point of view, most interestingly, RDF from XML using XPath. So YARML, you've got to say this in a pirate voice, YARML. So YARML is a human-friendly text-based representation of RML rules. And that's quite important because when you looked, and if you saw my demo jam last night, the RML I wrote was about 70-odd lines, and that transformed into over 500 lines, I think it was, of RML. So it's much easier to write YARML than RML. So it's a subset of YAML. A few other people have talked about that, so it's a human-friendly representation. So this is an example of a YARML mapping file. So we start with declaring some prefixes that we want to use. I'm going to use FOF. Actually, that's a typo. That top one should be FOF. And I'm going to use the waltonsexample.org as my base URI for the Waltons people. And then if we look at this in the mappings here, so I'm creating a mappings for people, which uses a Waltons XML file as a source. And the little squiggle XPath means I want to use XPath. I could use JSON path there if I wanted to. And my XPath statement, which is a mapping for a person, is from the XML file. So the root element is gedcomx, and a person is what I want to refer to as one of my people. So then the next two parts, the subjects. So this is where it turns it into RDF. So you've got the subjects, which is the RDF subject. So I'm using my prefix of Walton's example person, and I'm taking the attribute ID from the person, and that will then become my URI for that person. And then my predicate objects, so it's just the predicate is the A, which stands for RDF type, if you're familiar with that, and FOF person. So I'm saying that this is a FOF person. So if I use that, if I transform that, that's what I should end up with, a URI, a triple, basically. So I can do more XPath. So let's say I want to use the given name. So from the context of the person, the name form part, this is just the XML structure of the gedcomx. I take the given name, that's an abbreviation I've used there, it's actually got a full URI in front of it. And I take the attribute value and map that to a FOF given name, so that gives me a FOF given name of John. And I can do the same for last name, so you can start to see I'm starting to build up some RDF here. So there's John Boy. And in addition to the basic functionality of XPath, you also have access to GREL functions. GREL functions are from the Open Refine framework. And basically what you can do here is in your predicate objects, you can say instead of an XPath, you want to use a function. And then you pass in the parameters, and you say what you want to get back, which in this case is an IRA. This is a very simple function. All I'm doing is replacing, it's a string replacement. Happens that they put a hash in front of the ID, which I don't want, so I'm removing the hash and replacing it with nothing. So there's lots of possibility to manipulate the data using functions. The RML parser, so once you've written your URML mapping file, you can parse that into RML using the RML parser, which is just a JavaScript command line interface. And that will generate, so calling the parser, parsing the input is the URML file, and I want to create an RML output file in turtle format. And you can actually do this online. Again, I showed that in the demo jam last night. There is an online tool you can use for this as well. And then the final step in the process is to take the, so you can use the RML mapper. The RML mapper is a Java library provided by Family Search, and you can use that to generate your linked data from your RML rules. So in this case, it's just a Java command line, and I'm passing in the mapping file, the rules TTL, and the output is going to be the Walton's TTL. And you might be saying, oh, where's the input file? Well, the input file, if you remember, is actually encoded in the rules file. So that's already baked in there. And that will give you some RDF. So you can see here that, so first person here is John Boy Walton. And we've got some parents identified. They could actually be on the same line, but so we've got this one here. And if we look at that ID, we'll see that that is John Walton Sr. And the other one is Olivia Walton, his mum. And we can also see that Olivia Walton has a spouse, which is, of course, John Walton Sr., and a child, which is John Walton. So we can easily create lots of RDF in that way. So conclusions of this piece of work. Well, first of all, I would say it's possible to build a substantial personal knowledge graph quite quickly in this way. When I ran this across my own family tree, which fortunately my mum put together some years ago, so lots of detail in there, it created over 5,000 triples, which would have taken me months to do on my own by hand. There's also the possibility to export, so it's quite a limited amount of data that I've shown being exported there. There's actually potential to add a lot more data to the GEDCOM, so through whatever tool you use to create the GEDCOM, you can often add things like residence, employment. There's lots more information you can add in there, so there's the potential to extract that and turn that into RDF. There's also the possibility of adding information to your personal knowledge graph from other sources using the same technology. So basically, if you can get hold of data, it could be text message data, could be email data, whatever. If you can get hold of that in XML format or JSON format, you can write YARML, which will enable you to turn that into RDF, and you could then add that to your personal knowledge graph. So it's a nice, easy way to do that. And of course, the open world assumption that you have with linked data means that once I've extracted all this information in GEDCOM format and turned it into a knowledge graph, I can add more information. I can add whatever properties and links I want to add into those resources. So where do I see this going in the future? Well, obviously, there's a number of steps I had to go through to achieve this. I had to use a command line interface. I had to use a mapper. I had to do there was also a step to transform the GEDCOM 5 into XML. So these things could be chained together in a workflow. I could use something like Apache Hop to do that. And that would mean that I could create this data essentially at the click of a button. So if I can do it for myself, I can do it for other people as well. There's also, once you've got this personal knowledge graph, so what I'm interested in doing is being able to link that information into the journal, and I've got a number of different ideas about how I could do that. But one possibility, of course, is named entity recognition using a tool such as DBpedia Spotlight, which will locate named entities in your text and link them to the correct resource. And the other thing that I've been looking into, as I mentioned earlier on, is the idea of being able to share this information. So if I extract my family data and create that and turn that into a personal knowledge graph, well, I might want to share some of that with other members of my family, for example, because we share the same grandparents. So it would be nice that they wouldn't have to do the same thing, that I could actually share that. And to solve that problem, what I've been looking into is using Solid, which is the project initiated by Sir Tim Berners-Lee. And yeah, the idea is that you can actually potentially provide very granular access to resources, but we're not quite at the stage of being able to demo that yet. So maybe that's sometime in the future. Thank you very much.
Thank you. Thank you very much. Maybe you have a few time for a question. Okay, you're first.
I was planning to ask a question that said you haven't said anything about it, and then it appeared in the last line of your futures slide. I did a fair bit of work with genealogical data and GEDCOM, and people still sometimes download my GEDCOM to XML converter. The interesting trend to me with that kind of data has been moving away from personal databases to linking with other people's personal databases. And it's sort of, the pendulum has swung to having a global database of everyone's genealogical data. And to me, the big problem is genealogical data tends to be 95% accurate. And when you link it all together, the inaccuracies multiply. And you get the whole issue that people aren't maintaining provenance, and when you discover an error, you can't propagate the correction and things like that. So I wonder if you've sort of given any thought to the whole area of inaccuracy of data, which is intrinsic to this kind of data. And incidentally, it's not just genealogical data. I hit the same problem. I did work with a project that was doing criminological databases, which are a lot less than 95% accurate, yeah. and where correcting errors is incredibly important. But this linking without totally integrating and losing the origin is a subject that very much interests me.
Right, so my perspective on that is that I'm creating a personal knowledge graph. So it's very personal to me. So I'm creating something that I want to use, and my default position on that is that it's local to me. It's probably offline. It's probably not, you know, it is currently offline. It's not something I'm currently sharing with anybody else. So it's more like, I see it as more like a personal notebook or diary. So I'm responsible for maintaining the data in there. So yes, when I come to share it, absolutely, I can see potential for conflict or disagreement about information, but the things are very personal to me. So I might see something differently. I might see something about my grandfather which is different to how my sister looks at my grandfather. So I guess my position on that is I think it's okay to have that, because this is my, you know, and if she disagrees with me, that's up to her. Yeah, so I guess that's my take on it. But in terms of quality of data, yes, absolutely. So I believe in defining a data model for these things. So my personal knowledge graph would have a data model. And once I have decided what properties I want to use and what triples I want to create, then I would create shackle shapes, or, you know, I would define those in some way so that I can say, you know, I've extracted this data. Does it meet my personal quality requirements? But yeah, that's what I say.
Yes.
I've also built a very small prototype personal knowledge graphs because I saw some other academics doing it in the RDF world. When I listened now to you, I found it interesting. I was just wondering, it would be great, I would like to know what you think about it, if you have a personal knowledge graph with your basic data, which everyone constantly needs, the banks, insurances, every time you do a contract, and you could somehow push on a button and push it to them so you don't have to fill out forms anymore, you don't need appointments. I think that would be a great use case.
Yeah.
Or what do you think about it?
Yes, thank you. I agree. That's a slightly different use case. I mean, I see exactly what you're saying. How this would integrate with that, I'm not sure. I guess I see a personal knowledge graph as a whole bunch of stuff. It's genealogical data is one thing that might be in it, but absolutely, you know, I would potentially keep my personal address information in there, and I agree with you that, you know, I might choose to share that with organizations. That's why I'm very interested in the solid ideas, because that gives me the potential of me, I own my data, so I own my address data, and I share that with organizations. And if I move house and I don't want them to see where I'm living anymore, then I don't show them my new address. I just, you know, so I control my data, that's the idea, yeah.
Okay, one last question.
Robert, you know that I've done a lot of work in this area as well. And what I thought maybe I missed it, but I didn't get how. So you've got the data that's there for you to link to, but it didn't seem to solve your original problem, and it is a problem, of the time-consuming exercise of going through the text in your journal and actually making that link to your knowledge graph even. Did I miss it? I mean, did you do that, or is that another future?
Okay, so what I've done up to this point is I've spent quite a bit of time going through actually my dad's journal and working out what's in it. You know, what do people write in a journal? Which is why I came to the three kind of key things, the very general things, the slightly more specific things, and the very personal things. And that's what I found over and over and over again. So yeah, that was a huge amount of work, looking at that and working out what was in there. But that's not, what I would be interested in doing is, as I write a journal, that as I'm writing it, I link things as I go. So yeah, this is building something for the future. It's really, yeah.
Okay, thank you very much again. And now we have a break for 30 minutes. Oh, yes, 30 minutes.
Thank you.
Okay. So, last three presentations are going to start. Thank you very much for keeping up. And then we are talking about things about types. So we keep that for the last leg. So, O'Neill, floor is yours.
Thank you, Mohammed, and thank you, everyone. It's the challenge of speaking in the last segment of the conference, looking at the positives. You get the opportunity to listen to all the talks and try and make linkage to the things that are important and see where it all fits in. So I had a lot of time to think about that. But just to start, does anybody know this bridge, where, you know, the name of it, where it is? No? Yeah, so yeah, that's the Genealogical Bridge. If I say it right, forgive me. Yeah, thank you. So it marks the border between Berlin and Brandenburg. So as you can see, this talk is all about bridging between XDM types and native type systems. And just a bit of history, it was the bridge in the Cold War was the border between West Berlin and the East. For those who don't know who I am, I'm O'Neill Delprat. I work for Saxonica. This paper I've co-authored with Matt Patterson. So dealing with XDM through an API rather than directly in XPath, XLT, or XQuery means wrangling different type systems. As you can think of it as writing a program in Haskell using only Java as one example. Saxonica are the developers of Saxon, the XLT and XQuery 3.0 processor. You can add to that schema processor as well. We also are the developers of Saxon C, and I'm going to talk more about that as we go through, which implements all of that in a library accessible directly from C, C++, PHP, and Python. This talk is loosely halved into where we talk about designing APIs that work, looking at issues around APIs that make possible and even enjoyable to work with XDM from a different language. And the second part would be digging deep into the implementation details and the technical issues and issues that we have to contend with to make it all work. So to start, I have to thank Matt here for sending in his part as a video, so I'm going to play that now. All right, no audio, that's not a good start. Can we, it work?
Connected to the audio jack.
Okay, let's go back a step. It's plugged in.
Yeah, but maybe in your laptop you need to say that it should use audio for jack for audio,
Okay,
not the HDMI.
Let's do this again.
Let's start by looking at...
Yeah.
Okay, good, thank you.
Let's start by looking at the issue from a higher level. So what do I mean when I talk about type systems, and what do I mean by this gap between them? Just for the sake of simplification and speed, we can consider a type system to just be the way that various core objects of a programming language are structured and interact with each other. We can talk about concepts like inheritance, and we can talk about the idea of primitive objects, primitive values. And what do I mean by primitive values, primitive types? We mean things that can't be broken down any further, like an integer or the object class in Java. When we talk about inheritance, we're usually talking in the context of object-oriented programming. We're talking about objects that are built upon one another, and objects that are built upon another object gaining the functionality of that first object. So here, we can look at a very simple diagram of some classes in a type hierarchy with object at the bottom, node and string both inheriting from object. Obviously, an interesting wrinkle here is that we might consider in many places string to be a primitive type, but in Java it inherits from object. The obvious difference with XDM, which we can see here, is that the most primitive object, the most primitive type, the one that all other types inherit traits of in XDM is value, the sequence, which is a collection. This is a kind of inversion of what we might normally expect from a type hierarchy. And while it absolutely makes sense in the context of XML processing and the manipulation of objects in XDM in an XPath-like language, it makes their manipulation and especially mapping them to native types, that's the types in another language like Java or C, more complicated. With apologies to Matt Neuberg, who coined the phrase the English likeness monster to describe the idiosyncrasies of AppleScript and the way that its syntax work and don't work, we can think of the pervasiveness of sequences as pulling the constituents of XDM further away from the standard or conventional objects we would expect in, say, C++ or Python. Values, sequences, are the simplest type. But all atomic values, so strings or integers or whatever, are also one-item sequences. This is very different from anything in pretty much any other language. Now let's talk about string values in XDM in comparison with other languages. We can say some things about strings in XDM. All these statements are true or kind of true. That the length of the XDM atomic value representing the string hello world is 11 characters in hello world. That the length of the XDM atomic value representing the string hello world is 1, because there's one item in that sequence. But also that the length of the XDM atomic value representing a string that contains an enormous number of characters is also 1. Obviously this is kind of facetious, but I hope it illustrates the point. But the functional nature of XPath makes the oddness of XDM go away. We can't invoke the square brackets operator as a method of a map or as a string. We have to use the inbuilt functions to do that. So there's an inbuilt and natural disambiguation that makes a lot of those complexities not relevant for us. Map get is very different to square brackets operator, which can be used in other languages in many places to do many things. We're going to look at numbers just briefly, because converting between different kinds of number types can be a difficult problem. Here are the various XDM number types showing how they're derived from each other. There are quite a lot of them. And here are all the JavaScript number types. Hilarity ensues. This is enormously problematic for number conversions in JavaScript because there is only one kind and it's a floating point. I mean, it's enough of a problem in JavaScript as it stands, let alone interfacing with XDM. But I want to move on. We do need to take a closer look at maps in XDM. Consider a simple XDM map. We get the value corresponding to the key A using mapget, as you can see here. Of course, we can also call the map to get the value because a map item in XDM is also a function item, so it's callable. But obviously it's also a value, so we can index into the sequence represented by the value to get the value out, which is slightly confusing. compare this with a Python dictionary, which is the Python data structure closest to a map. If we try and index into it as we would if it were a sequence in XDM, we can't. It just explodes because it doesn't have numeric indices. It's just got keys, and 1 is not a key of that map. What do we need to be able to do in order to provide idiomatic local language API access to maps? Well, we need implicit and/or explicit conversion between XDM and native objects, direct mapping between types where that's appropriate, and well-documented rules for widening and narrowing type conversions like those with numbers. But that leads us to another question. Whose idiom is it anyway? Aspects of XDM make the most sense in XPath using the idioms of XPath. But the languages of our APIs have their own idioms. And those are not, as we have seen, exactly shared with XPaths. So we have a couple of things going on. We can talk about competing conventions. What do you choose to represent a certain kind of access to a value in a native language when the obvious choice makes sense for several aspects of that, like square brackets with indexing into sequences and fetching values from maps, or even slicing a string and getting substrings out. Another interesting thing we could look at is whether we can use the context we're operating in to just be ignorant of certain aspects, to basically to ignore some things that make our lives difficult in the native languages that we don't really need. Because maybe it's okay to ignore some of the XDM aspects that make no sense in the context in which we're operating, the context of manipulating a value in Python or in C++. Why should atomic values be sequence-like in Python? It doesn't make much sense. Maybe we can just allow them to not be sequence-like in our APIs. Those are the kinds of questions we're having to deal with, and those are the kinds of issues we wanted to discuss briefly before O'Neill comes back to talk about some of the more technical implementation issues we've been dealing with working across multiple languages and multiple type systems.
Right, so as I said, we're linking between what's been spoken before. I mean, Mike yesterday gave us an insight of the 4.0 specs. It was interesting to see navigating JSON documents and the operation to do that. So it's something that's fundamental, and it's always going to be there. No matter how, from the early days, even now, we have to navigate documents. In XPath, it's powerful, simple, concise, succinct. / person can get you all the persons in a document. You can do more clever things, filter and navigate back up the tree quite easily. But when you now start to build APIs, you've got to think about the structure of that tree. Think of these nodes as objects and how you represent that in memory and things like that. And if you consider now how you would do that in an API, this example here is in Sax and C++ code, to be specific. Given you have a node object for this exact same parsed trees that we have, we can get all the children. You can iterate according to a certain axis. We just want to interest in the root axis here. We get the first child and then try and go through all the child nodes. And you can do a lot of things, but why? Already you see that this is verbose, this is error-prone, but at the same time it's giving us the power to do useful things. to connect to multiple systems. But as a C++ programmer, you have to manage the memory, delete things after you finish with it. That sort of thing is the memory management is for the user to take care of. Some more code examples. Think here, think of an XML document which has a lot of package elements, and we want to select all the packages that have an attribute with role equals secondary. In Java, you can use the stream API in Saxon and it's quite elegant already. You can use stream API to get all the package elements according to the attribute with role equals secondary. Even in Python, you can do similar thing here as well. So already the APIs are trying to make it easier for the user. The focus here is more about Saxon C and dealing with some of these issues in a multi-tier system. Saxon C is exactly that, because it's built upon the Saxon Java product, using GraalVM to cross-compile it to a native library. GraalVM is a JVM implementation that provides the ability to compile the Java code right down to its native representation. It comes packed with everything that you would need to execute the application. But also you can use it as a library to connect to other languages like C++. So the core languages are Java, C++, back and forth. And we provide extensions to Python using Python and PHP as well. Just to mention, actually, how we use GraalVM to do this, GraalVM has some nice APIs to allow you to expose the Java methods as entry point annotations. You just have to mark it with annotation to say, I want this method to be exposed to the C++. And it provides you with that. These methods are now exported in the native library. But there are problems that we have to address. As I said, it's a multi-tier programming language. The Java garbage collection can get in the way. If you're in the C++ world, as we saw in that example, who knows when the garbage collection is going to be triggered? We have to prevent that from taking away objects that we're actually using. We're now in a C++ unmanaged code, communicate with managed code. And on top of that, we have extensions in PHP and Python, which is, again, managed code. So it can get tricky. Firstly, to address the garbage collection in Java issue, GraalVM API provides us with an object handle. So it's a representation which allows us to, what can I say, take that Java object and provide it into the unmanaged code, C++. It also provides us with an object handlers pool, which is just a set. So within the Java world, any object that we put into this pool, it stops it from being garbage collected. But as implementers, it's our responsibility to remove it from the pool so that if we're no longer using that object, it can be garbage collected as necessary. So this is just a structure of what's going on. So we have some layers. The application layer as a user, we want to write code in C++ or PHP or Python. We communicate directly with the extensions or with the underlying C++, Saxon C, C++ API. There is a thin GraalVM C API layer, as I mentioned before. And within the Java space, you've got the object handlers pool and the Saxon core code base as well. So any object in the object handlers pool won't be garbage collected. So that addresses one problem. But what about the garbage collection happening in PHP and Python? And this is where it gets complicated. So consider this code. I think it's Python code here. So we parse an XML document, which is node underscore, and we pass that to a processor, XLT executable, with the context being a node underscore, and there is some output which is a value as well. And at the same time, we want to do something after that where we set this node object as a parameter to the executable. What happens to node underscore at this point? So Python being Python, it says, well, there's no references at this point, at this point. This node object's not used, so garbage collect it. But we're using it as a parameter within our processor. So that will cause problems. So when we now further down in the code or in some other part of the code want to use that parameter in some other transformation, it's not available. And that causes problems. It will crash. Look at another, so just to mention actually, the assignment prevents this garbage collection from being triggered even from line 2. Because it says, oh, this node has been used. But what happens if you're not assigning this data? So in this example here, it feels like this mic is chipping in and out, but I'll continue. We're making an array object, and within that, we are adding values to that array. There's nothing being assigned. So on line 3, the behavior is undefined. Garbage collection may trigger it and then crash because this object's not needed anymore. That's what it thinks. I'll try and be quick here. So how do we overcome this problem? We have to do our own memory management. And just as Python and PHP is doing, we use our own reference counting of the objects. We can get a bit clever about it and cache child nodes as well, but even that can be complicated because how do I know that this node, this child node has been passed on to the user? Whose responsibility is it at that point? So we have to sort of track access to these child nodes, XDM items and things, and it can get very complicated. So looking at this example, I've sort of combined it here. So we parse the XML document. That node underscore has a reference count 1. It's been passed into an XLT style sheet, and we know that it's within that operation line 2 that the ref count can be decremented. The output's got reference count 1. So right at the end, the node will have a ref count. So we sort of trick Python to say, okay, we're using this object still. So don't try and garbage collect it. And just to conclude, we've opened up and made it possible to cross that bridge. The XCM view of the world is different to the way that most host languages structure data. XCM wrappers that bridge between the worlds need to be a first-class part of the API. I call these first-class citizens. It just can't be an afterthought. You have to think right up. How are we going to communicate between these multi-tier systems? It can be difficult, but we want to do more than just one-shot transformations. And that's what we started with Saxon C. It was like libXML. You just do one shot, and then but you want to do something more sophisticated. Looking back at the history, and it's nice to be able to lean upon what Mike thought of many years ago with dealing with this sort of problem. It's not quite gone away, but it's become more complicated. Because we're wrangling with expectations of managed code in core Java runtime and the managed code in the host language runtime. It is complicated. We still have a lot of room to improve, and we hope this survey, at least at the higher level challenges, I haven't gone too deep, is been useful to other implementers as well as to us as well. Thank you. Any questions?
Thank you.
O'Neill, thank you.
I'm asking a question out of utter ignorance of someone who never deals with this low a level of programming. I gave up on memory management as an undergraduate, as something I never wanted to have to do again. How much of a hit is a modern typical XSLT or XQuery processor taking if you took the drastic approach of simply saying, no garbage collection? We're going to let memory just pile up, and luckily everybody's laptop has 8 gig nowadays, or 16, or whatever it is. I hear lots of no, no, no. That's not going to work, right? That's not a viable solution, is it?
No, it's not going to work, because in the C++ world, then there is no garbage collection, but you are working with a system it's in Java, so you have the garbage collection there. And then you're trying to support people in other languages which have garbage collection, so yeah. It would be nice not to deal with it, but we're not in that ideal world. I've got Matt as well to answer questions, so yeah, sorry.
Thank you for your presentation. You show on one slide some kind of this pool of references. Is it some new API of GraalVM, or is it just the JNI create global reference?
Sorry, can you say it one more time? I think I understand, but let's say it one more time. Sorry.
On one of your slides, you have this pool of references.
Yes.
Where you talk to not to not garbage collect the object. Is it something new in GraalVM, or it's just the old JNI API create global reference?
It's in GraalVM.
Okay, thank you.
So it's available to you. So it's just object handle and the object handles pool. Or it's a set really, but I just call it the pool.
So maybe one quick question? No. Thank you very much.
Thank you.
And thank you, Matt.
I'm going to talk about diffing XML. And I'm Martijn Vaassen. I've been programming in a variety of languages. Years ago, 20 years ago almost, I created the LXML library for Python and dealt with some of the issues just discussed in the last talk. So that was quite interesting because I was binding to libxml2. And more recently, I built a tool with Peligo, who hired me to do this, a diffing tool for documents, XML documents. And Peligo is a company in Sweden, and they make a CMS also called Peligo for technical documentation and sort of other knowledge management style data. And it's docbook based, so you can kind of imagine why diffing XML documents might be useful. Yeah, diffing XML, you have two documents, a source document A, a target document B, and you want to be able to express the differences between them. And yeah, it's the last day of the conference, right? And it's 5 o'clock. Yesterday at 4 o'clock, I was already very tired. And I'm going to talk about how this algorithm works to you all now, so, you know, enjoy. Yeah, here we have a very dumb source document, and we have a target document, and you can see that the C element has been inserted, and there's a little annotation here now created by the diffing tool to show the difference. So what were the goals of this project? Well, obviously we wanted to create differences between documents that were correct, right? Like not the wrong differences. And specifically, we want to be able, like given the diff document that I just showed, we want to be able to reconstruct both the source and the target document successfully. That's sort of a test of validity. And that's a necessary goal, but it's not a sufficient goal for a diffing library, because I could just write this diffing library that always did this, just throw away the source document, and then insert the target document. It's always valid. This is fine, right? It's correct. I'm done. Please pay me now. But yeah, that's not good enough. We want human-readable diffs. You want diffs that are a bit like what a human would actually, how they would express it. And they wouldn't say, oh, well, I threw away the old document and I wrote a whole new document and it's entirely different. They would say, I added this C element, right? And there's also a few non-goals, like we're not aiming for like the technically most compact diffs, even though compact diff there might be overlap with human readability there, and it's not about the most efficient sort of diffing approach either, and it's really specifically about documents rather than data. So think about diffing docbook, for instance. And the algorithm that I didn't come up with myself, but I'm getting ahead of myself. It uses the text content of the document to help try to make better differences. And the algorithm could be used to diff any XML, but the quality will probably suffer because there's less sort of textual document style overlaps to sort of anchor the diff. And it was also important that this is production quality. It shouldn't just be, you know, a prototype. It should be reliable and maintainable and fast enough also for moderate-sized documents. Large documents, really big ones, I haven't tested it on. For moderate-sized documents, some of the systems that I looked at that already exist struggled even with moderate-sized documents. And since I'm here at the XML conference, and I'm kind of new here, first time at an XML conference, I have sort of this question about where this name XML came from, because, you know, Bill Gates, as everybody knows, invented the internet, right? Bill Gates invented the internet, not Al Gore, that's a lie, it was Bill Gates. So since I'm new here and there's this XML thing and it starts with X, I was kind of like, Elon Musk, he's really into the letter X, so I figured that, did he implement, or did he invent XML? Is that the true story, or am I missing something? Anyway, let's look at diffs. You know, what kind of diffs? There's a bit of notation. Red, without any special marking, is delete. Green, with underline, is an insert, and blue is just an updated piece. And I've used indentation in these examples, even though that would really screw up diffs if you start indenting things, but it really helps with clarity, so I've indented stuff here. So inserting, we already seen. Now, all right, what did I do? Is it picking up again? Well, now we're going to delete, and that's very similar. So we just mark the element with that it's been deleted. And you can also like modify text. So here we're adding the word or the string world with the exclamation mark, and that's marked up with a text insert element just to show that that has happened. Similarly, deletion is the inverse. You can also do stuff like attributes, right? If you know that an element, well, if you suspect an element is an update of another element, then you can express, you know, somehow, the details of this don't really matter, but there's an element inserted as the first child that sort of describes the changes to the attributes that have happened. And it also should support the other XML stuff, processing instructions and comments. And then there's like a few kind of more slightly higher level operations. So here we are not, world was already in the original text, we're only adding an element around it. That's like a wrap operation. And it's different from the insert where the whole thing is inserted. And you can also, well, that's expressed like this. So there's a wrap attribute on the B element. And you can also do that for unwrap. And other diffs are possible, but I haven't looked into them. like move operations. There's all kinds of sort of fancier, higher level diffs. The more fancy you get, the harder it might be to easily represent what the diff is, but that's sort of the collection I showed just now is more or less what natural XML diff supports. So, you know, I started this project and it's like, okay, how do you diff XML? How do you come up with a way to do that? And I had a starting point, an XML library, or an XML diff library, Python library, implemented by a friend of mine who referred this project to me. That's based on a paper from before XML, so really old now, I guess. But the problem with this library, my Pligo had tested it, it didn't really produce human-readable diffs on various sort of small examples. And it struggled also, like, performance-wise with even medium-sized documents. So I looked at it, thought, can I improve this algorithm? And I thought, well, let's step back, let's look at the literature, see what people have done with XML diffs. How do you do an XML diff in the first place, like a tree structural diff? And then I had a stroke of luck because I found a 2020 paper that did a whole literature research of, you know, the last 20 years or so of XML diffing tools, and it focused on document-style diffs, which is exactly what I needed. And it compared and tried to estimate their quality, like how good is this to a human being? Does it look human-readable? And so I was very happy. Thank you, authors, for doing all that work for me. And I also learned, we want human-readable diffs. This is not just about a generic tree diffing algorithm, it's really about human-readable diffs. And the paper that, the overview paper had a candidate that stood out called JNDiff, and I tried it out and it worked well on our test cases, and there were a bunch of papers explaining how it worked. But there were a few problems. There was a code base in Java, and it was last updated 10 years ago, and it had comments by the academic developers of the software in Italian, and it was hosted on SourceForge, so it's kind of like, yeah, that's kind of what the state of that is. If it's on SourceForge, it's just resting, I guess. But the paper described the algorithm, and the source code was there. So I took a good look at that paper and decided that the best way to sort of create a maintainable version of this stuff is to try to re-implement this algorithm, was described, it looked doable, and to really focus on making production quality and fine-tuning it where possible. And I chose, because I have a hammer, in my case that's Rust, I chose Rust as the implementation language. I like Rust a lot. Ask me about Rust. It's like a systems programming language that avoids some of the problems in memory management that C and C++ have, and yeah, fits this domain fairly well because you need the performance. So how does JNDiff work? Well, the key insight, and I already sort of referred to it a little bit earlier, is that you have these sequences of identical content, like the text of the document, including the markup. It sort of anchors the rest of the difference of the diff. And what it does first is it sort of flattens these documents into arrays, because it needs to do a lot of comparison. The algorithm really needs to do a lot of comparison operations, and you can do that faster if you just flatten them first into arrays of node. Like in document order, you just flatten it all out, and you have the same information. And then it does something called partitioning, and what it does is it looks in document A and B, like on the top, and it looks for like things that are exactly the same, like a sequence of nodes, not a XDM sequence, an array of nodes that are identical between the two documents. It tries to look for that and looks for the longest one. So it does a lot of comparison to try to find sort of this, and then it finds the blue bar, and it has found this overlap, and then, well, it has two halves left, so then it starts looking in those halves for the longest bit that's available there. And then it keeps doing that recursively until it cannot find any identical nodes anymore. And then you have the left. And I stole this, I didn't want to draw the tree myself, so I stole this graphic from the paper about JNDiff. But you see here, like on the top is like document A, and then you have document B here, and you see here I've identified like whole sections of the document in green in this case that are just exactly the same. And it doesn't have to be like a rooted bit, it can be a fragment like that. Then, you know, you have the gaps left where there are no exact overlaps, but you still suspect that somebody has edited the text and there will likely be overlaps. So we assume those things in the beginning. We start out, okay, those things are different, but then we look for similar text nodes on the A and the B sides in those remaining gaps. And we use the Levenstein algorithm, and then we find like text nodes that are very similar to each other. They have to be like 50% similar, otherwise we don't count them as similar at all. We find the most similar ones, which are like, you know, change one letter or something like that. And we remember those are updates, and then we partition again like what we have left. So we try to look for more updates. And then, yeah, again, I stole this. See here that there's like text 5, which is the string content of the node, that's the text node, and then text 25, so a 2 got inserted, and you know, this algorithm then identifies what the update was. And then there is a process called propagation, which means that the information that's like you have ancestor nodes still, that have maybe a lot of updated nodes sitting under them or identical nodes under them, but we cannot identify them as identical as equal yet or updates yet. But now that we have a lot of nodes sitting underneath that we know are, or you know, yeah, we assume are updates or are equal to each other, we can propagate that information. So again, we take like the longest, weightiest, well, in this case, the pieces with the most text, and we propagate that information upwards. So we can identify like these. There's a lot of different potential algorithms or heuristics you can do it. So this heuristic, there's no perfect algorithm for doing mutable diffs. So you can tweak that quite a bit, which I actually did. And then once you have sort of marked everything, so you've marked like an element as equal, well, then there's no edit, it's just the same. But if you have on the A side, you have a different element, you haven't been able to associate it with anything in B, then you assume it's being deleted. And if you have something different on the B side, you find an element and it's different, you haven't found an update or an equality there, you assume it's an insertion of that element. For text nodes, if there are updates, we can do like a text diff, and then determine what piece of text was inserted. And attribute changes, if we have done our propagation work right, we can find like what has happened to these attributes here. So yeah, when I got the recommendations about how to write a presentation, then I said, well, you should have not more than 20 slides. And we're at slide number 55 now, so I'm doing it wrong. But whatever, let's continue. So I implemented JNDiff algorithm, and then I started testing it with data and taking a look at sort of how well it worked. And then I found a bug. It's always sort of a good sign that you've implemented an algorithm or a paper or a specification correctly if you find a bug in your code, and then the bug actually also exists in the original, which was true in this case. I tried it with JNDiff, and it had the same bug. So JNDiff thinks that these two XML documents are the same because all the nodes occur in the same order. So if you linearize them, they look the same if you don't look at like parent relationships or things like that. So yeah, that's a problem because they're not the same. I fix it by detecting like propagation inconsistency, that if you have something that's considered to be the child of a node in one document, but it's in the other document it's not, there is an inconsistency that I could, and appears to work reliably and resets that so that they are different. So that fixed that issue. Then something that is mentioned in the JNDiff paper, but I actually finding an implementation of it in their Java code base, and the paper was very sparse about how this was supposed to work, is like detecting wraps and detecting unwraps. So I have multiple algorithms. One is related to that, and another one that I'm going to discuss later. Find these things, and again, it's heuristic. You don't always find all of them, but yeah, it does a decent job now. The other thing that I did that the JNDiff tool does support, and the XMLDiff Python library also supports, is to produce some kind of diff document that describes the difference. But I really focused on this diff document because I found it much easier to reason about than a sequence of inserts and deletes, delete operations for the many situations. So yeah, here you have your diff document, and I had insight you could refine this diff document. You could refine a list of edits and post-process them, and you could merge or transform these edits, but it's easier to reason about in a diff document. So here's an example, and I found these quite a lot. These were sort of left after the JNDiff document process was done. I would find a combination where a paragraph is deleted, and then another paragraph is inserted. And the deleted and inserted, the content is really different, right? So it hasn't identified it as an update because the content, the text is different enough. But I found that if I merge them, and I say, well, no, I have a paragraph node, and then you have a text insert and a text delete in there, that would actually really improve sort of the quality and readability of the diff. And then another observation was that if you have like multiple deletes and multiple inserts, it turns out that you can reorder deletes and the inserts sort of next to each other, but not their own order. Their own order has to stay the same. Optimize this by reordering stuff, by moving stuff around, and then we suddenly can do merge again, and then we end up with this. So that also really helped improve the quality of the result. And then we left with mixed content. The special thing that XML can do, basically, right? Especially document style, XML has a lot of mixed content, and you would sometimes have a situation where a text node was identified as an update of another text node, but then there was like a bold or something like that, a bold element, and then there was another text node, and really that should be part of the same diff. We figured out a way to optimize these diffs using plain text diffing. Because plain text diffing is already optimized for human readability. Like these algorithms have been designed to be readable. And I was inspired by XML because I found a little algorithm that did something like that in there. So here's an example. This is a difficult to understand diff. Some text gets deleted, an I element gets deleted, and then there's another text insert. But what basically happens, if you reconstruct the source and the target, which you can do from the diff document, you have the pink big elephant and the pink elephant. That's basically all that happens. So really, you would like to see the I element deleted, but because of various issues with text updates and processing things, this wouldn't always happen. So the idea is to replace the mixed elements with placeholders and take these placeholders from like a Unicode reserved code page where you can freely use them. They won't never overlap with real Unicode characters, and replace that stuff and remember what replacements you've done, and then do a plain text diff. And then you get like some nice information, and then you reconstruct the XML again from that. And that also really helped improve the diffing result. Then you get like, you know, delete big, which is the thing you would like to see as a human being. And it turned out that this post-processing would have a cumulative effect where this combining of delete and insert pairs combined with this further cleanup stuff would sometimes like really, especially in translated content where the structure is the same, but it's different, it would really make that a lot more readable and really express it as text differences instead of element differences. And then, yeah, I'm getting sort of near the end. Robust software, you need to test it. So I started out by writing automatic test cases for various diff scenarios that we knew were interesting or problematic. A general system to verify that when we have a diff document, we can always construct a semantically equivalent A and B document, again, from that diff document. We implemented property testing, like randomly generate like documents A and B, some kind of tree, and then check whether that still verifies that that property holds, being able to reconstruct. We had a lot of test data, and we did bulk verified testing against that to check whether it's working. Wrote a HTML visualization tool so we could actually eyeball the diff, because that turned out to be really useful with that merge scenario and stuff. You could really see cases where, hey, this is weird, we can do that better. And I also implemented a simple like metric that I could at least optimize for the size of the diff in the amount of text change. Like if you have like the same two documents and you're diffing out, you tweak your diffing algorithms and the size of the changes that are described are smaller, that's a hint that you might have something going on. Then I thought, okay, I need to add another joke here, because after all, you know, after 5, we're all tired, day 3. And yeah, it's probably 6 now or something like that. So I'm tired, and so I went, you know, I hear all these talks about AI, so GPT, and I said, well, you know, hey, what's a joke about automated software testing? And then I, you know, I'm tired, I can't think of any, please help me, ChatGPT. And then it's like, sure, here's a joke about automated software testing. And it's like, why do automated tests never laugh at jokes? Because they always take things literally. And I was like, okay, I don't get it. Is that funny? And then ChatGPT, to compound on its error, the thing you should not really do is to start explaining the joke in great detail about why it was supposed to be funny. So anyway, so yeah, there are some challenges left. It's in production now. I mean, yeah, Rust is really amazing in how much compile time checking you can do. So it's really solid in the sense there's no crashes or anything like that. The performance is adequate. Also, the diffs produced, you know, are valid, but a use case sort of turned up that I wasn't aware of, and we weren't really aware of sort of initially, is that sometimes with the diff visualization, you don't want to visualize the diff as an XML, but you want to visualize it in the original you know, we're using the original rendering system, like you would render DocBook or something like that. And then you can run into issues with the rules of the document, like certain modifications produce a diff document that is a valid XML document, it's a valid diff, but it's not a valid DocBook document. So that's a whole giant can of worms, and I'm currently sort of trying to imagine ways to manage that can of worms, because the whole algorithm right now is not schema aware. There's a few things you can exclude certain attributes from comparison, and I've also fine-tuned it on the data I have, but it's not really aware of a particular XML schema, and now that might be an issue. Purely with the visualization, it's not like the diffs are wrong. So yeah, in conclusion, natural XML diff sort of has practical improvements over many of the publicly available XML diff implementations. It's a high quality it produces high quality diffs thanks to the J and diff algorithm and some of the improvements. It appears robust over a wide selection of documents, and we intend to open source it. Any questions?
Thank you very much for the talk, especially as you mentioned to kind of find wraps and unwraps, because that is the only use case for updated content that is not otherwise changed. I was looking forward to the rest of the talk, but then when you talked about the necessary post-processings, I got the feeling that using the text-based approach, you lost something that is present in solutions that use a tree-aware, XML-aware approach by basically comparing element nodes and looking for identity at that level and knowing about the structure, and you kind of rework some things that they have for granted. And so solutions that take the XML-aware approach, like finding similar elements based on longest common string, selection, Levenstein, whatever, and they kind of have the problem to detect the wrap and the unwrap. Because then if you unwrap something, the element is deleted and the text is inserted. But that is again something that in post-processing could be fixed into, oh, this text is the same and we mark it as updated. So I personally don't see a hard preference for this way to go, because you need some post-processing, you have to do some handling afterwards. So from my point of view, it would most probably come down to raw performance, like comparing the available tools in terms of performance and with large documents, because that's our use case. We have basically, let's say, our customers doing 800 pages documents and creating diffs from them. And on the publication pipeline, we of course handle all these special elements with the namespace.
What is the question?
The question is, I think I would like to see an update of that talk. I would like to see a challenge kind of talk, and you did not convince me until you said you like to open source it, and I would say we're looking forward to that.
Yeah, I mean, I think you do have a misapprehension. It is a structurally aware diff. The post-processing is just part of the whole algorithm, so it's not some kind of weird thing that just happens afterwards. I'm just describing how the algorithm works. And the algorithm that is doing the longest common subsequence, sort of that whole analysis of creating identical nodes and update nodes, information is not lost. The processing that happens is after we have identified elements with mixed content, and specifically mixed content, that are very similar to each other, then we can do some more work to produce better diffs, which is, I think, you would want for documents. So that text processing, and that diff is also structure aware. It doesn't throw away any information about the identity of nodes there either.
One more question.
Hello, I would like to know, how do you decide if a difference is an update or if it's a simple deletion or insertion?
The decision is made by if you cannot find an update, like if you cannot find something that looks sufficiently similar to each other within those gaps, so it could have moved also, and then it will become an insert and deletion. But if it's in the more or less the same place in the structure of the document, that and you cannot find an update, then it must be a delete or an insertion. That's basically how that works.
Yes, next question.
Thank you very much. I thought that was really interesting, and I think some of the insights that you added later on were really clever and really nice. And I think you said this is your first XML conference, so welcome to the family. I want to ask a really weird and annoying question, so I'm going to begin by saying I've worked on DocBook for a long time, and if you want to chat about how to make the diff documents that will be valid DocBook, hit me up and we can talk about some of those things.
Thank you.
My weird, annoying question is, can you talk a little bit about your choice of attributes for marking diffed things? It looked like they were names with empty string values. It just struck me as a little...
The name, basically the name of the attribute is the same namespace name as the original. So the name of the element is the same name as the name of the attribute. That's why, so that I could reuse the element name for that information.
Okay. Last question.
Thanks for a very interesting and entertaining talk. I'm just wondering what you do about insignificant changes. You mentioned briefly white space, which makes me think that you're treating all white space as significant, but also how about things like attribute ordering, which between two different documents is defined as being unimportant.
Yeah. Attribute ordering is considered unimportant. That's not a diff, right? That's not part of the semantic model of the XML document. White space, I have like, you can turn that on and off, but you can remove, well, what might be insignificant white space, right? Before you do the diff, you can normalize sort of the inputs. There's a bit of code that does that as well.
Thank you very much.
Thank you. To get rid of my...
Thanks for that, Jacob. My name is Ari Nordström. I've been doing angled brackets since they were called SGML. I've been also doing a lot of other things, among them film projection, which I wanted to mention because there was a person from Dolby here yesterday, and I just have this Dolby fetish.
Go ahead.
I own, I don't know, 12 old Dolby sound processors meant for cinemas. So yeah, leaving that for now, I'm going to mostly talk about VIN numbers, data, and a bit of IXML. And so let's just start. Right, vehicle identification numbers. If you own a car, you will have one of those. It will be stamped on your engine block or maybe on a steel plate, on the windscreen somewhere. You can find them pretty much anywhere. The weird things, they look like this, sort of 17 characters of information. Now these list the config of that particular vehicle, and they can actually, they can identify an individual vehicle. And if you look at them from a slightly different perspective, you can see that they're position-driven things. So you can parse these sort of things, and those of you doing IXML will know where it is leading. VIN numbers been done in the US around 1950s. But it's been a painful road for them, pun intended. And the fact is that even today, some 70 years maybe after the fact, this kind of is and isn't a standard because, everyone should have their own standard. And that's how you do it. So you can see here that there are plenty of standards, but they all implement it differently, and they don't always implement it the way this table says. I grabbed this from Wikipedia. It's sort of half true here, but close enough. So there's a lot of standardization to be had here. And I'm not about to suggest anything like that, so let's go on to the next topic. Yeah, I know, obvious, right? Data profiling. How many of you know what data is? Fair number. All right. So a data looks like this, and I'm not interested in explaining to you a whole lot about data, except for these things here. So one thing about data, firstly, is that it's all about building blocks, and it's all about reusing those building blocks in any number of ways. But reuse is easy for the first 95% or so. The last 5% are always a nightmare. So what most do today is this is by no means only data. So data is an example. I'll get to that in a bit, why. But you have a product attribute here that says this particular topic applies to product A, and it applies to an audience equaling experts. So you might have, another value saying beginner, product B, C, D, etc. But importantly, remember that building block analogy, because that's what they are. You combine your building blocks into usable topic manuals. So a single data topic doesn't have a context. It's supposed to live by its own. It should completely describe a topic. But since you need to profile those sometimes, you need to tell that this applies to product A and audience experts. It's not that easy. Now, data's got something known as maps. They're basically just more XML linking to those topics, reusing those topics in some order, in some fashion. Maps are what creates hierarchies for data. So there's no chapter hierarchy in data, in a data topic. So here, in this case, we've got a map linking to 3 topics. The first one is applies to product A. Second one doesn't have a profile, so it applies to everything. That's the logic. If it doesn't have a profile, it always applies. It's always included. And doc3 here, the third topic, is about product B. So if you publish that map in context A, so you're just sending it out to publish, doing some XSLT and some XSLFO, getting a PDF, and if you say to your publishing process that I want it for product A, this is what you get. You just exclude everything that's not product A, or doesn't have profile. So they select a subset. They select a profile, some perspective of that total map. But we can profile anything, not just the topics themselves. We can go inside a topic. We can say that this paragraph applies to A, this applies to B, and this applies to everything. And when we publish that in context A for product A, this is what we get. Again, we exclude something that is not important for this context. There's plenty of system support for data, obviously. Our friends at Oxygen have loads and loads and loads of support. Publish this, so you can go home and test profiling, and it will just work. I'll show you one system then. So things happen in context. My context here is that I was building a portal, thing built on XDB that serves XML documents and publishes those documents on the fly. Those of you who listened to my talk at Balisage last year will know a lot more about that portal, because that was a topic by itself. Importantly, this is publishing, again, data on the fly. So we store data as is in XDB. we click buttons and we can publish. Let me see if I can do a very quick demo. So this is a live version of that portal. You'll see, I'll just sit down because this tends to go really badly if I'm standing still. So we can, for instance, and this is test data, by the way, this is some customer data, so I'm not going to publish anything. But here, you can basically select your profiling attribute. Remember that product, remember that audience. So we might select audience, and we'll get a selectable list of profiles for audience. Happens to be regions for this particular manufacturer. Or we might select engine type, and there's going to be a single profile there, and I can do a search. And up here, you will note that I found my single topic with the profile petrol_EU4. That's an actual thing, by the way. No idea why it's called EU4, but it's an actual thing. Let me go back to the portal then and the slides. So you may have guessed that interface was all XML technologies. That was an X form. We're obviously converting the data on the fly, so everything we see there, it's from the actual sources. For instance, the file list on the right, that's a list of XML files generated by the database and presented in an X form. The browse button is another example. You can actually look at the data map structures. That's why you see all these browse buttons here. So that file list is a bit of XML, pre-generated, because if you have 1 or 2 gigs of data, that will take a while with everything. So it's pre-generated, so you can just serve the right kind of file. So if we look at the file list here, single file, can you see this properly, hopefully? For instance, for a single file, I'm obviously pointing out where it lives, because I'll need that information. For data context, I'm also saying that, well, this thing here is applicable to these 2 profiles. Audience, same thing. There's always some data notation that is useful for processing later on. It basically says the same thing here. Loads of other things, it's just a subset. Obviously, you need to list the title, because otherwise your X form would be empty. And you saw this one. This is another X form. We just select things, and once I'm selecting, I'm clicking search, as you saw. What happens in the background is that it generates this tiny little piece of XML, which is the filter. So I'm basically just applying this filter to my file view to get what I need to show, reorder the list, and put them on top, or anything else I might want to do. So thinking about VIN numbers for change again, because a VIN does describe a configuration of a vehicle, a car. It will also describe applicability, but it's very different from a data profiling approach, 2 very different things. And I can tell you that there's no standard implementation of VIN numbers, because there is no standard in several, and most of those are tied to ERP systems, the things people use to handle their businesses, that sort of thing. And the question becomes, can we actually combine those 2? Well, glad you asked, or me. Because, so IXML, I read Stephen's paper in, I think, 2013. when it first came out, reviewed it, I thought, this is really cool. I wonder if there's a use for it, and I couldn't see one, but that's just me being stupid, right? I again read sort of a slight development of that paper for XML Prague a year later, maybe half a year later. And I said, still very cool. Can't see a use there, but I mean, it's a nice exercise. Yeah, that's me. That's how stupid I am. I'm not going to explain how that works because Steve did a much better job of that. But essentially what you do is you express a grammar of your implicit structure, basically like EBNF or something like that, if you know that sort of thing. And you then are able to serialize that in XML formats, which is really cool. You make explicit markup. So I'm not going to do this because this is just your dates example. I think I borrowed this from either Stephen or Norm on the website. So if you have a date like this, you can get XML like this, and I'm not tidying anything up. And I suppose you'll see now where this is going, because VIN numbers, for this client, again, there are several standards, so that would equal several grammars, different, and they would not be compatible with each other because they do implement those 17 positions very differently, some of them. But this particular client has, and it's not this one you see here, but they've got very well-defined use of VINs. So I thought, how hard can it be, right? So I wrote an IXML grammar for that, for the VIN. It was an Excel spreadsheet, actually, with all the values listed, all the letters and all that stuff. So, for instance, here's the actual expression. You've got things like the manufacturer ID that always comes first. This, by the way, will frequently, not always, dictate the rest of the string, but that's neither here nor there. And so on vehicle types, for instance, you got commercial vehicles, you got private vehicles, so, ambulances versus private citizen-owned vehicles, that sort of thing. Model years, all that stuff. It's just a grammar. So we can now serialize this thing as XML, which is kind of cool. So let's briefly go back to that demo again, hoping that this will work. I will need to fix a value here. So the actual portal is very highly configurable. So, and this is a config file. So I can do any kind of thing. And so if I go back to the portal and refresh, we are going to get a new X form. So just if I start writing, it will just start complaining. There's a check going on, making sure that I don't mistype. I don't want to mistype, so I have that on my clipboard. And now this lookup VIN button appears, so I can look up the VIN. This is actually slower for some reason if I share the screen. I find that really interesting, because it's instantaneous if I don't. So I can list what that VIN number actually means very specifically by parsing that string using IXML. So basically what's behind the scenes here is basically more X forms and coffee pot by Norm. And so, let me see, it's a bit tight here. So if I look for that, voila. Again, at the top, I'm finding my petrol EU4 document. This time, I'm using the VIN to find the exact same thing. So going back to the slides. Well, you saw this, no need to go into that much further. I'll say this, that the values you see there, they're all raw values. The actual client implementation translates all of that and localizes it. So it doesn't actually say vehicle type or platform or engine type, camel case or anything like that. It just spells them out. But that's nor here nor there. What can we do with the XML that is produced by CoffeePot? Well, we get this sort of thing, and the filtering you just saw was done by converting that thing into a tiny little XML that filters my file list and gets me what I want. But I can also generate what is known as a DITA-val filter. So for those of you who know DITA, that's kind of an XML file that is sent along with the rest of your DITA when you're publishing, and that is basically a filter that gives you that context in which your DITA map is published. So I can just generate those, and it just works. I'm not allowed to show you what happens when I publish, because there is customer information in there, but this talk was not about that anyway. The cool thing is, though, you can also go in the other direction, because if you have your portal, so you have the live implementation does have a lot more values available, so not just audience and product and engine type, all kinds of things. So you can also go in the other direction. So you can play around with your profiles. I want, car for the New Zealand market, just the left-hand drive, just the petrol EU4 engine. I don't know if that's a thing, but you can do that. You can convert that back to a VIN number. So it's kind of a round trip. And if you think about that, you can actually generate a range of VINs. So if you're doing a recall letter, say, as a car manufacturer, you don't want to send that email to everyone. You just want to send that to those affected. So you know what profile that is because you're looking at the portal, you're playing around with the profiles. But you can then use that to generate a VIN range. So not just a specific VIN string, but the range. You can also use that for any number of other things. You can use the range to actually find spare parts in an ERP system. So SAP, for instance, you might just feed that into loads of my customers are into Salesforce, which is a horrible, horrible thing, but that's what it is. And you can just feed that into Salesforce and you'll get loads and loads of parts applicable to that particular individual car, which is kind of cool. So, in closing, I think that I was so dead wrong about IXML, so it hurt. So I wrote this paper and I wrote another IXML paper for Balisage to be presented in August. And it's really cool in practical, the real world out there. So next steps for this one is, well, you may have noticed that there wasn't all that much actual profiles in the DITA. That's a problem. It's not an implementation problem, it's a source problem. They need to enrich the DITA if they're actually going to use this thing properly, which they really can't because the DITA content is not smart enough. Now, I do need to expand the VIN grammar because that basic grammar covers the only manufacturing plant they have. They will have new model years. That's dictated by one of the ISO standards that dictates how VIN numbers work, but they're not in the grammar currently. There may be additional features specific to a new model, things like that. So the grammar needs to be updated. And the Vim-based integration with ERP systems, that's yet to come properly. So with that, thank you very much. Any questions before we close this conference?
We have time for questions. Oh, yeah.
Very interesting presentation. I also came across Vim once, and I also realized, oh, that's a lot more complicated than I would have assumed at first sight. Is there, I mean, there must be some kind of definition what actually, like semantically, is a Vim or not? Or, I mean, it's not just cars, it's motorcycles, I assume, trucks. Can you be sure that when something has a Vim, that it's not a boat or a, I don't know, plane?
You can, but you need to look at the registry, because most of these are registered. They're not standardized, but the manufacturing code that starts 3 characters, I believe, that will tell you what it is. Well, sort of, because then the 4th and the 5th, I believe, would tell you what kind of vehicle it is. For this manufacturer, they have 2 basic types, or 3 maybe. So it's not a problem, but you cannot universally rely on that because you have these differing implementations. And this car manufacturer, they are based in Europe, but they are closer to the US definition of VINs for whatever reason.
So I saw, great talk, thank you, really interesting, great to see it being used in the wild. So I saw that for the year, for instance, you converted them into element names like Y22. Is there a reason you did that rather than doing insertions and just having one element year and then the content with 2022?
Yeah, so you'd need to match those to letters in.
Yeah, but you can do that.
You can certainly do that, but it did not occur to me at the time. His answer is as simple as that.
Okay, all right, good.
Yeah, thank you very much for the talk on the the practical insight in how industrial tech publishing, what the challenges are. And you mentioned that the companies have in their ERP systems, they know everything based on the VIN. They know the color of the car, they know the tires initially shipped with the car, and they most probably know in which country the car was shipped originally. Mm-hmm. And some even take track and change the car, changes ownership. They get notified and they can kind of send, if you have the car bought in Germany and then sold to someone in Finland, mm-hmm. and that person in Finland has the chance to get the original manual in Finnish based on the original specs of the car.
Oh, absolutely, yes.
And so there is a lot of the full bill of materials is in there, and the car industry is kind of lucky that they have this VIN specification. Every machinery manufacturer nowadays, they have just the serial number, and they have their back-end system, hopefully, and they have exactly the same problem enriching the content to make this. What I once read a paper that how you create the content is, the name for this that I read once, it was master document and fragmented reuse, by filtering away everything you don't want. That is one way to do it. There are other ways as well, getting all the information from the beginning, the sales process, through to manufacturing and documentation, getting that through, that is the main challenge in the industry, to enrich the content, as you described with these examples. And so I'm very happy that is our daily job to handle things like that. And that was a very practical example of how XML and automated processes work. Thank you very much for that.
Okay. I should add that so you would think that the VIN was somehow the truth and nothing but. That's not the case. So the VIN will cover a basic configuration. It will not cover everything. On the other hand, the ERP systems will have other information. They will have sales codes in addition to your VIN number. Those are mapped in the ERP. There's no standard for that. But there's more information as part of your sales code and the relations in that database. And I could even add to the fact that if you look at the engineering data, you will most likely have, a PLM, SLM system like Windchill or Teamcenter, and you will have, again, very different metadata. So.
Thank you. I have one question. I find the proximity between Wien and Diesel at the same sentence confusing, but that's me.
Do you need me to address that?
Sorry. Okay, no other question? Thank you very much.
Thank you.
Yaka, what do you think?
I will have to see the schedule.
Oh, yes.
We are 2 minutes later, so there is no time for closing.
Oh, yeah, okay. So bye-bye, everyone. Thank you. No. Thank you very much. Again, thanks to all the sponsors. Thank you for traveling that far, coming across all the world to come to this beautiful Prague city. I want to invite the people that are doing this conference. And see you in
somewhere.
Nobody knows. Maybe 2 years. Bye bye. Take care.
Thank you very
Travel
much.
safe home. Thank you.